mennä.
Good morning, everybody. How are you doing? Excellent. My name is Antti Merilehto. I will be your host for the next 2 days, and I'm really happy to see each and every one of you for the Euruko live event. Give yourself a big applause. You made it here. And on that same note, I just heard the latest number. Already there's 600 of you here. We will be roughly 700. So even though the prime seats here in the front are still available, as always, some of them, especially later on, you might need to squeeze. So if there's a seat right next to you that is not taken and you're not reserving it for special someone, you might need to squeeze, and that's okay. Just briefly, housekeeping issues. For the talks, outside keynotes will be going 30-minute talks and 10 minutes for questions and answers. We will be using Slido. There you have access via Brella. And also regarding Brella, you have the networking possibility. So please register, please use Brella for that. And of course, please ask questions. I will be getting to details on the lunch and all that later on. But let's get going. It is now my pleasure to ask on stage from the organizers, Matthias. Please welcome.
Hello. So I think this is the longest Euruko in the making. This was supposed to happen in 2020. It's been 2 years too long. But let's kick off with some thanks for our sponsors, especially to Cookpad, our first sponsor that we ever got. And we... They actually agreed to sponsor us even before we secured the venue, so it was great. They let us pay for it. And, thanks to Shopify, and our second Ruby level sponsor. I'll run through these very quickly because we're a little bit late. Go check out their booth. I think they're hiring, maybe. And then at the gold level, we have Meister, Florin, and the aforementioned Brella. And let's not forget our other sponsors as well. At the silver level, New Relic, AppTweak, TechSoft, and Scout. And also our bronze sponsors, Fishbrain, BuildKite, Gisco Labs, Clark Silverfin, and Zoom Kumar Sapiens. And then just a reminder that we do have a code of conduct. If you violate the code of conduct, we reserve the right to eject you from the conference without a refund. So make sure you're being nice, as Matz would be. And if you spot any issues, then first and foremost, look for us in the crew hoodies, or then somebody from the venue staff can direct you to us. Or online through Discord, you can tag or message the moderator roles. Or you can call us, and that will reach one of the organizers. And feel free to take a photo of that number for the future use. Or then you can email us, but that will be the slowest response time. And as Antti said, please go register for Brella. You should have an invitation in your email, or then you can just log in with the same email that you used for your ticket. And Umbrella, you'll find a link to the Discord as well. And there's the Wi-Fi, and there's signs outside as well. And we have a space on floor 0. We didn't choose the venue just because the floor numbering. If you need to work somewhere quiet, you can go there. And then tomorrow we have lightning talks and city pitches. So lightning talks are a maximum of 5 minutes, and then if you want to submit a proposal, just email lightning@euruko.org with your name, the talk title, and a very short description, and then we'll email you at the end of the day whether you got a slot or not. And then the same goes for the city pitches. It's also a 5-minute slot, and then just email your name and what city you're pitching. And those will be immediately after the lightning talks tomorrow. That's it for me. And next up, we'll have the keynote from Matz. Thank you.
I just love this guy. He straight down to business. Any case, any questions? Just grab anyone with the crew hoodie, whatnot. But let's get going. Like I said, we have Matz. This is pre-recorded. Like George Carlin once said, when are you going to record it afterwards? But this is recorded. However, after the keynote, we will have Matz joining us virtually for Q&A. So please use Slido. But at this point, let's go to the keynote.
Hello there. Hi. This is Matz, the creator of the Ruby language and the keynote speaker of this conference. So the pandemic has several side effects. One of them is, I have less chance to speak in English, so that I have never had the chance to visit the other country like Europe and the United States, so that I have less chance to speak in English, so that my ability to speak in English is getting worse and worse. So that next 45 minutes, so that I try to give you a better explanation in English, but you have to stand. I'm sorry. Anyway, this year, I'm going to talk about the Mythbusters. But before that, let me talk a little bit about the kind people in the internet. I have been using internet for a long time, probably more than 20 years. And there are so many kind people in the internet. Actually, too many of them. For example, at the very early stage of the developing Ruby, that I got the email that says Ruby is too good to be a scripting language. In that mail, so that he claimed that scripting language for the scripting languages, programming language for the software, the script, which is mostly less than 100 lines. So that Ruby is too good to be a scripting language. Okay. But in fact, that kind of the power or goodness of the Ruby as a programming language makes us, happy and productive. So that it couldn't be too good to be the programming language or scripting language. About similar time, I got an email. The scripting language do not need object-oriented programming. But back then, the scripting language, for example, in say the Perl, which was still in version 4, was not object-oriented. And then the Python was a newcomer, and which has the object-oriented programming. But those newer programming scripting language are less popular at that time, and he thought the scripting language did not need to be object-oriented programming language. Yeah, but I think we proved he was wrong. Before Rails, we struggle to find the killer application for the Ruby language. So that at that time, many people told me no one used Ruby, and then they used Perl, PHP, Python, or whatever languages other than Ruby. Or there's no killer app in Ruby, they claimed. Or this is a nice one. You shouldn't have created Ruby. We should focus on Perl for the sake of the human being. That if we concentrate our effort to the existing language like Perl, and then not waste our effort or power to developing new languages, so that we could have better Perl, better programming language, and that serves human beings better. Yeah. yeah, thank you. Or some people claim that Ruby is slow. Or this is recent ones. Web age is over. Web age is over, and we have artificial intelligence, machine learning, or even Web3. So that in those hotspots, the Ruby is not really popular in the domains. So that Ruby is over, or Ruby is dead, or Ruby is dead every year, or Ruby is not their favorite language like Rust, Zig, Go, Python. Okay. They irritated me. Not because they insult Ruby, they said they told me bad about Ruby, but because they are not fair. In Japanese proverbs, the Tora no i o karu kitsune, which is the fox that borrows the authority of a tiger. And that if someone who created the language, like Guido who created Python, or the Larry Wall who created Perl, claim that their language has better aspect of Ruby, and they're comparing those two languages, and this is good, this is bad. We have trade-offs, and then the exchange of the ideas, and to create better programming language in both sides. Okay, that's okay, but most of them create just the audience. They're just a third party. Just try to irritate me. That kind of attitude irritates me. Being majority, for example, being as a member of the Python community or Rust community does not make them superior. Okay, the point is we have to seek the real value. We found out the most values end with Y. Ruby is a value. And the productivity is community and joy and money. All of them ends with Y. This is the site which is the top Ruby companies, which is created by my friend. This is the list of the Ruby companies sorted by the total value, total market cap value. The top ranking as a market value is the Airbnb. The second is Shopify, Square, Coinbase, Zendesk, and then a few lines before that, GitLab, the Procore, On Running, Kaulfuss, Monday, Braze, the list goes on. Those companies are, okay, $60 billion value. And this, at least part of them, for Shopify, the almost all of them are created by the software or services written by Ruby. Okay, we are creating huge amount of market value. Okay, this is another list. Okay, this is a the 50 software companies sponsored, helped by the Y Combinator. Then we have many software companies sponsored by the Y Combinator. And then the top of the list is Stripe and Cruise, Airbnb, DoorDash, Twitch, Instacart. And then some companies use Ruby, others use Python, C++, and the other technologies. But for statistics, 13 companies out of 50 are using Ruby. It is 26%. But as a total valuation, 52% of total valuations are from Ruby companies. That is incredible. That is incredible. So that, yeah, we can ignore those noises from the internet. As long as we create value, we create value. So that we can just ignore the noise and keep moving forward. And then I believe the best part of Ruby is velocity. Velocity of development. Well, we can say productivity. The velocity also ends with Y. And not only higher productivity, it means the quick to deploy. If you have a task to solve, if we can finish earlier, finish quick, that is value. And that kind of the quick solution and solves most problems. That quickness is the very good aspect of Ruby language. And the Ruby is right now is the top popular programming language. I know that. I admit that. But the popularity comes and goes. We should not dangle in the wind. Okay, in 2010s and 2020s, the static typing is a cool kid. The most popular programming language, Rust, Go, Kotlin, Swift, whatever, or TypeScript. And even Python and PHP has type annotations. But back in 1990s and 2000s, the dynamic types of programming language, Ruby and Python and Perl, those are cool. Those were very cool programming language. Those programming languages, a pretty hot programming language in 2010. But these days, JavaScript has the dialect with type annotation, which is TypeScript. PHP adds type declaration to the language. Python adds type annotation to the language. So should Ruby add type annotation or even type declaration to the language? I don't think so. Because we have several misunderstandings or even myths around static typing. The first myth is the static typing is newer. The newer programming language like Rust has very popular on the static typing. And then, the functional programming languages like Haskell or Camel has static typing. And then they are very popular recently. But as a fact, the static typing is even older. Remember that Fortran, the world's first programming language, is statically typed. And static typing is even older than dynamic typing. The second myth, static typing is better. This is kind of the controversial. As a fact, static typing has several trade-offs. Let me explain. Okay, static typing has so-called pros, like a comprehensive checking. We find type errors in compile time, so that without executing comprehensively, so that this is very good things. And the type declarations works as documentation. So the programming language like Haskell, so it has the very strong type inferencing. But as a convention, the Haskell programmers write down the types of arguments and return values because those declarations work as documentation, which is consistent with the programs. Okay, Ruby programmers, of course, write inline documents like RDocs and YARD, but they are fundamentally comments. So that if we are too lazy to update the YARD document, that could be inconsistent with the actual methods or functions. So as a type declaration is part of the program, so that there's no chance to be inconsistent. That is good aspect. And when we have the type declaration, type information from the programs, that we can provide the better ID support, like the code completion or the documentation pop-ups, or the refactoring, or the many things. And in addition, by using those type information, the compilers can optimize software better using those information, so that the static typing helps better performance. And I admit those are true for most of the compilers. But at the same time, the static typing has some drawbacks. For example, basically the the type declarations are verbose, and it's against the conciseness, which is the good aspect of the programming language. And it's basically redundant because the Ruby does not have type declaration, but we as a community experience the writing software without type declaration. So that fundamentally those type informations are redundant. So it's kind of against the dry principle. And then some type declarations could be very, very complex, and some people prove in their papers so that the type declaration of some languages like C++ or TypeScript are Turing completed, which means that you can write down arbitrary algorithm in type declaration. So it could be, tremendously complex, which is, far beyond our understanding. So that, a few days ago, I saw the YouTube videos that shows the solving the tic-tac-toe in the type declaration. That when you write down some kind of the tic-tac-toe pattern in the type declarations, so that the type completion in VS Code shows the black wins or the red wins or something like that. that is kind of insane. So that that kind of the type declaration can be very, very, very complex. And then and I'm a bit worrying about if we adapt the type declaration to Ruby languages, we might see the type policing in Ruby community. We have some experience in the other programming language, like some gem authors or some library authors has had claims that your library should have a static type declaration, or otherwise your library is pretty bad or something like that. That is not, that makes the atmosphere of the community very, very, peaceful. Yeah. So do we really need type declaration? Yeah, we admit static typing or static type information has those benefits I described before, but do we really need type declarations despite those drawbacks? Okay, static type checking is good, I admit, but we don't need declaration to check. That is why I introduced the Ruby 3 static typing, which is the static typing without type declaration. The typing information in signature files, which we call RBS, Ruby signature. And then, in addition, we introduced the Ruby gem RBS correction, which is the TypeScript, the differently typed counterpart for Ruby gems. And then for Rails programmer, one of our committer, Poke, is creating and updating the RBS Rails, which is the signature for Ruby on Rails. And then we also provide the typeprof, which is the signature generator. So that typeprof use the technique named the abstract interpretation. So that scans your software and generates the prototype of signature for your applications. And then the typeprof also does a simple type inferences, and which is pretty good. And then we have Steep, which is the signature-based type analyzer. You can find those type errors using Steep, which is and then the typeprof also works as the language LSP language server protocol server, so that you can use the typeprof to provide code completion based on types or something like that. By those and forthcoming tools, we can implement, we can get the comprehensive checks of comprehensive static type checks using typeprof and Steep. And it also works as a documentation by using LSP. And then better ID support we can provide using the typeprof. And we also working on improving the LSP server, which we can experience better and improve the productivity of the Ruby programming, which is very, very, very good. So as a result, we can get the benefit of static typing without declarations. So that, and I also has some kind of long-term vision. Tech trends comes goes. Remember that some 10, 15 years ago, the dynamic typing was pretty popular. So the next 10, 15, 20 years later, the other type of programming will be popular. So tech trends like a pendulum, like comes and goes. Maybe in 10, 15, 20 years later, language with type declaration might become popular using those techniques. So that maybe we have better type inferences, and then maybe we can have better tools support like LSP, so that we don't have to struggle with the Turing complete complex type declarations, but the software and the supporting tools helps us to write the type safe, statically checked, but with the type declarations, writing better software in programming language like Ruby. So that I kind of foresee the future like that. So that is, that's kind of hard decision. But I want Ruby to be one of those languages, the popular in, the 20 years later. So that nobody knows future. Nobody knows the future. So that we cannot tell with what kind of the future really comes. But I foresee that kind of future for the programming language and the typing. The mostly statically typed programming languages without type declarations. And it also has the flexibility of dynamic typing, and also has the conciseness and the power of the language like Ruby. But I want that language would be Ruby. But I try hard to make it real. That is the reason. That is the reason I'm not going to add type declarations to the language. I'm not going to blame other languages like a PHP and Python, but I believe, I made the right decision in 15 years. Yeah, trust my forecast. Or not. Myth number 3. Dynamic typing is slower. Compared to the statically typed programming languages, the dynamically typed programming language like Ruby tends to be slower. Yeah, that's the fact. But remember, the statically typed programming language, the most of the statically typed language is natively compiled. The technology-wise, the virtual machine language like Java or JavaScript or even Ruby needs not to be slower than statically typed programming language. The V8, which is the Chrome JavaScript virtual machine, is a good example. The V8 is the virtual machine for JavaScript, which does not have any type declarations. But it's blazingly fast because it uses the runtime type informations, and with JIT compilers highly optimized, so that the V8 virtual machine is faster than most virtual machines. Sometimes which is faster than the JVM in some benchmarks, which is wonderful. Which proves we don't need to be statically typed with type declarations for to be faster for performance. The V8 does not require type declaration to be fast. So the JIT compiler using runtime type information, that means the JIT compiler can use more precise type information than the declarations. With the runtime type information is reality. When someone declare these arrays is the array of objects in the statically typed programming languages, but in reality, for most of the cases, they are the array of say symbols. But only a few instances it has some strings instead of symbols. In static type declarations, it should be the array of objects, because of its elements is either symbol or strings. But no, the runtime type information knows these are in most of the cases those elements are symbols, so that you can highly optimized version of the method for the array of symbols. And you can run small, element check before calling that highly optimized version. By using those kind of techniques, the JIT compilers sometimes runs faster than ahead of time native compilers, native compiled code. So the performance is very important for Ruby as well. That's the reason the recent years we highly invested in the JIT compiler in Ruby. And this year 2022, so that we replaced the YJIT, which is the newer JIT compiler, in Rust. So that our new JIT compiler is written in Rust. Because to implement, to support ARM64 new instruction set architecture, the previous JIT compiler written in C is too complex and too difficult to manage. So the YJIT team, sponsored by the Shopify, tries to use the modern programming language to fight with the complexity. So that they replaced the Rust version of YJIT. Then a few months later, so that they come up with the ARM64 support for YJIT. So that now YJIT runs for the ARM64, which is Apple Silicon, or the CPU for the smartphones. And then later, the MJIT, the older version of our JIT compiler, was rewritten in Ruby this time, which is we can hook those JIT compiler in Ruby to experiment the JIT compilers. Now we have two JIT compilers in Ruby. One is MJIT, which is the some kind of the experiment testbed, and the YJIT, which is more performant and realistic. And as long as I've heard from the author, the development team of YJIT, there are plenty of room to improve performance in YJIT, so that we can expect the future performance improvement by YJIT. This is quite, sounds promising. Okay, and we are going to release Ruby 3.2 in several months and in Christmas. So that this Ruby 3.2, we are going to have the Ruby on WASM, which is WebAssembly. That means that we can run the full Ruby, not the subset of Ruby or the alternative implementation of Ruby, and full featured Ruby in browser, which is wonderful. The compiled version of Ruby compiled into the WebAssembly has several several megabytes. Like that is quite big, but in the considering the bandwidth of the recent internet, which is almost nothing, so that you don't have to worry about the burden of the data, so that you can run full Ruby in the browser. And memory allocation is improved. That we are going to introduce the shape And we are going to introduce the compaction, the GC improvement, the memory allocation improvement. And we are trying to implement the MN threading, which is kind of like a goes routine. So the M native threads and N over the N Ruby threads or actors. Well, we are going to have the data objects, and then we are going to have some syntax suggests gems, which is better error information providing, and then we also provide the error highlight, which is the better error messages. Yeah, we are also working on tools. And thanks to excellent tools, and we have RubyMine, SolarGraph, Rubacop, Sobase, Steeps, and then many more tools. And most of them provided by the community. RubyMine is from the company, of course. And then we can do more. And then as a community, we encourage the improvement of the tools, because I also believe the future of the language, the productivity from the Ruby language can be provided by those improved tools. So that if you are trying to improve the tools or provide new tools for the better productivity of Ruby programming, and then if you feel you need help from us, the community, so that please ask us. Yeah, we can help you to improve the productivity of the Ruby language. Anyway, as a community, we will keep moving forward by improving the performance, providing better tools, including JIT compiler and those tools, and the static type checkers, many more things. And we have kept moving forward for last more than 20 years, almost 30 years. And we try to improve language for long time, and for the future, to create better world. And I will invite you to join us to improve the developer experience and improve your productivity together. This talk is sponsored by Salesforce.com, which is my sponsors, and an initial company in Japan, and I get many GitHub sponsors, and mostly we have help from Ruby community. Thank you all. Thank you for coming to the conferences, and I wish I can see you physically next time. Thank you.
Thank you, Matz. And if we are lucky, we will have a connection just about now. Let me check. Hi, Matz. Thank you so much, Matt, for the keynote. And we have quite a few questions from our participants, so let's get straight down to it. First one is from Luciano. What do you think about Sorbet and other community initiatives around type checking?
The core community mostly invest in the RBI, RBS, the Ruby signature, and Steep, because we are not going to add any type annotation, even in some form of DSL. So for the future-wise, the Ruby community gradually move into the Steep and RBS, but at the moment, Sorbet is much better both in performance and the completeness. So if they need more precise type checking, static type checking now, they are going to the Sorbet. But if you are going to invest in the future, please try the Ruby signature.
The next question is the big regrets in life. Are there any language features that you regret introducing to Ruby?
I borrowed some features from Perl, especially some kind of very cryptic global variables. I regret them. In addition, I regret adding thread to the language at the very beginning of the language development, because at that time threading, most of the computers have only one CPU at the time, so that we focused on some kind of the descriptiveness of algorithm or architecture, like the producer-consumer model or something like that. But now we have many cores in a computer. So we mostly focus on improving the performance by threads. But that kind of difference is kind of became burden for our implementation. But if we could provide something like Raptor at the beginning, so it would be much easier to make do concurrent programming in Ruby. So that is what I regret.
Okay, thank you. The next one has a nice touch of longevity, looking way to the future. How do you think developers can support Ruby so that it thrives for the next 100 years?
It is quite difficult to predict the future, even in 5 years. So that preparing for the next 100 years is almost impossible. But at least the Ruby was beginning as a hobby of mine, my hobby at the beginning. But it's now community effort. So that we have to gather together and organize our effort as a community. That kind of the bookkeeping or the adding more powers from the community is the key for the survival for the next, say, 5 days.
Yeah, it is said by a famous Finnish politician, predicting is difficult, especially predicting the future. Thank you, Hannah, for the question. And next, again from Luciano, apart from type checking and speed, if applicable, which area do you see that Ruby should improve?
I think Ruby should be improved in the domain of interacting with the programmer, especially using some kind of the IDE, like the VS Code, code completion, or something like the GitHub Copilot or something like that. So that by help from the tools, we can be more productive using Ruby. So that in the future, even without the type declaration, we can infer, the tools can be infer the type of the expression or variable, and the tools can do better code completion or maybe some better interaction with the programmers.
Thank you. Next one comes from Vesa Vanska. Do you have any idea how to encourage Ruby library authors to provide RBS types?
We are working on the Gem RBS collection, which is kind of the counterpart of the definitively typed in TypeScript. So the users can provide the signature information as a gem. The gem authors can easily import that RBS information from that repository, so that it is much easier for gem authors to adopt the signatures.
Thank you. Next, we have a personal question from Christian. What is an aspect of Ruby you currently enjoy working on?
I don't know, but I'm proud of inventing blocks in Ruby. That is the greatest invention in the language, I think.
There is a question also, if Ruby didn't exist, what other language would you pick nowadays?
Right now?
What would be the other language?
Probably, I'm not sure, but I like Julia pretty much. It has very unique aspect as a language, so that yeah, I like Julia. And what else? Maybe I'm working in, say, some kind of Lisp language, a common Lisp or something.
Okay. From Simon, is contribution to the open source projects a key to stay so positive after years of coding?
Probably. I think involving with the open source activity is to boost my joy of programming. Yeah, I have been working as a professional programmer for a long time, but the writing programs for the customers and writing software as a open source developer, so the latter is much more enjoyable, I think. But I have very higher motivation working with open source software. Maybe because of the freedom, I think.
There's one very specific. My colleague, CH colleagues tease me with their Visual Studio debugging capabilities. How long will it take until I can tease them back, and how can I help speed this up?
I'm not involved in any VS Code activity, so that I can say a little, but it's not that hard to to write the VS Code plugin, and you have to write down the JavaScript though, and involving the most of them are open source, so the involving to the it and improve the plugins much easier than some kind of the priority the commercial software. So that and step in and work together.
And one final question. You talked about the 3.2, but what to expect from Ruby in the future? This question comes from Attila.
Three things, as always. And the one thing is the improving the performance, like by JIT compilers and improving the memory management and improving the virtual machine implementation. We are going to improve the Ruby, the performance always. And say the Ruby 3.0 is 3 times faster than Ruby 2.0, and we try to make a Ruby 3.x somewhere, probably 2-3 times faster than Ruby 3.0, so that we are going to improve the performance, the one things. And at the same time, we are going to improve the productivity, performance of the development. And that is pretty much more important because of the productivity is more important than the performance. If performance is most important, then we don't use Ruby. That we use some kind of the native compiling language like C++ or Rust or even Fortran. But we use Ruby because of the productivity. So the productivity is very much important. Second things. The third things is the combination of improving the performance and the better improving the productivity, I mean, and along with the improve the performance, so that we can enjoy programming, so that we can do much trial and errors and enjoy programming. So the joy is, I think, most important for Ruby.
Great way to finish this interview. Matz, thank you so much for joining us.
Thank you.
We will have a 5-minute break, and then we go into how music works. So in 5 minutes, we'll continue. Thank you. And dear participants, this is the 2-minute warning because I see that there's not any more queue or line to the coffee stations. There's still line to the water station. So in 2 minutes, we will continue. That is 2 minutes. Thank you. Okay, let's get going. Please find a seat, just a kind of seat that you prefer. It can be in the front, it can be more on the back, whatever suits you. Those of friends of British TV comedy will find connotations there, whatever suits you. Well, I am going to go now. So, musicians and sound engineers have found many ways of creating music and making music sound good when played from a record. Some of their methods have become industry staples used on every recording released today. In the coming half an hour, let's look at what they do and reproduce some of their methods in Ruby. So, let me introduce how music works using Ruby by Thijs. Thijs, welcome.
Let me see if I get sound from here. I don't. Ah, there it is. So, welcome to Helsinki. Lovely place. I'm really happy to be here today. And today we're going to be talking about music. And what I like to do is I like understanding the world through Ruby. You know, the world is a really big, complicated place. And, you know, we are programmers, so we can use the language we like to just understand things a little bit better. And, you know, once you can write some code for something, you sort of actually get what it's all about. So that's what I did with music stuff. So I've been like making music as a hobby for a long time, and this talk is sort of the intersection between my two main interests, which is programming and music. And this is what I like to do. Like, don't understand it, you figure it out through writing code, and then now I'm here and I'm showing this stuff to you all. So we're going to go over a few things today. So we're going to do a really brief history of recorded music, and I'll show you how technology really played a big role in making that whole thing happen. Then we're going to look at what digital audio actually is and how we can visualize it, and we're going to do a few mixing tricks, and we're going to make some actual sounds. And there's a whole bunch of code, Ruby code for this talk, which you can find here afterwards. So you can kind of play with it if you're interested. So we'll get started by talking about what audio in the end actually is. So audio is it's a waveform. And we perceive that as having like, and to make that audio, to turn it into music, our brain uses pitch, timbre, and tempo to kind of create this illusion of music. So this is like a sine wave. So this is a waveform that doesn't exist in nature that often, but it's the most simplest thing that can have a pitch. And a waveform is actually quite similar to what you would see in a pool like this. It's kind of waves of air molecules kind of like bouncing against each other and making their way through a space like this one. So these bouncing air molecules, they're coming out of the speaker here at the moment, and they're kind of creating a chain reaction of air molecules all bouncing against each other in a wave. Eventually, they end up in all your ears. And in your ear, there are actually a lot of like little hairs called hair follicles, and they vibrate in response to what these air molecules do. That creates a little electrical signal, and that signal makes its way to your brain. And your brain magically creates meaning out of these vibrations. So humans are capable of doing language and interpreting audio waves as music. And the scientists haven't really figured out how this works yet, so I don't have an answer for you there. But somehow some magic happens in all our heads, and this music thing that most people love just appears. So how does the brain do this? In 3 different ways. So the first way is pitch. So pitch is the number of times that a wave like this oscillates. So this is a pitch. You know, the most boring one that you can come up with. This is just like a number of oscillations per second, and if you do different types of different numbers of oscillations, you get a scale like this. Yeah. So we already we all got this in primary school, and this is simply the same waveform, but just like happening more often than one of the other ones. The second thing that our brain uses is timbre. So timbre is about is what makes a sound like a violin sound like a violin, for example. So that would sound something like this. So this is all one pitch, and there's a whole concert just playing, creating a lot of like little variations within a waveform that just create more of an atmosphere, if you will, and are also a big part of music. And the last thing is tempo. So if you just do some sound sources and you put a little break in between them, we perceive that as a rhythm. And if you combine those things, you get like a little piece of really simple, but it is music. So I think this is really simple, like piece like this. It's basically nothing, but you already have all the components in place. And back in the day, music was always live, but then we got technology. So in the past, people just used to play around a campfire or something, and it would actually be like a communal activity. So everybody would join in and sing a little. And we kind of lost that through this process of moving everything into recordings. So this process really started in the early 20th century. So there's this guy called Thomas Edison, which you've probably heard of. He invented like a lot of stuff. And one of the things he invented was this machine called the phonograph. So this would, if you shout really loud into that hole, it will, a little stylus vibrates, and it makes a little etching on that cylinder. And that sounds like this. It's quite, it's like not a lot of fun. And this thing actually never made it, and that's because Edison patented it. So I think there are a lot of these kind of like technological things kind of echo through the ages, because it was patented, nobody could use the technology except for him, and nobody wanted to pay him a license fee. So this other guy, he was called Berliner. He came up with this phonograph concept, which is disc. So this is how we ended up with discs. I guess if Edison wouldn't have patented his machine, we would have like been walking around with cylinders for 100 years instead of flat discs. And the phonograph like started to sound a little bit better. Still not really a lot to write home about. So then we're kind of like getting into the nicer stuff. So the tape machines like actually sound pretty good. And yeah, that's the tape machine. Then the Second World War happened, and then the developments really accelerated quickly. So we got like tubes, and people like started making like really good microphones, and they started doing like multi-track recordings. So this is the Beatles with a lot of different mics. You got mixing desks and like transistors. Now then we got to the 80s, and everything became digital. We got CDs. For the younger people in the audience, you know, this also used to be something that you would play music from. And eventually, like everything moved into computers, and that kind of brings me to the point of where I'm here today. You know, people nowadays use software like this to make music, and we're going to like take a few components out of this program called Ableton Live and just recreate it in Ruby now. And to be able to do that, we first need to understand what digital audio actually is. So digital audio is a lot of samples in a row. So if you take this waveform, if you look at the little like edgy points, that's all the points where a sample is being taken. So it's basically just measuring how the intensity of the waveform at a given time, like thousands of times per second. And if you like recreate a waveform out of that, you get something that's so close to the original that you really can't hear the difference if you're a human. So we got a lot of numbers. And these numbers can be positive or negative. So this waveform is kind of like going up and down, and it's kind of going around the zero all the time. And the simplest format for audio is the wave format, and there is a gem for that can read that. So I'm using this gem to read the wave files and kind of like process them, and then we write them back to disk, and we can do some stuff with them in Ruby. So this is some code, some helper code that we need to kind of just read the wave file and just like make one really big array out of all the numbers in the audio. And once we have the big array, we can do some stuff with it. So that looks like this. So this is probably like a second of audio something. There's just a vast amount of numbers, and it's way too much for us to make any sense of it just by reading them. So we're going to need some visualizations. So we'll make some PNGs. And we also, in the Ruby ecosystem, we have a great gem to make PNGs, chunky PNG. And we're going to use that to create some images. So we're looping through all the samples here. And for every sample, we're going to like draw a little dot on a PNG image. And it's either going to be like on the top half of the image or on the bottom half of the image, based on if it's a positive or a negative number. So this code generates images like this. So this is like some real world audio. I think this is like some you know, like a car passing by or something. This is like pretty random stuff. There's a lot of these little dots. But if you visualize a sine wave, like this one, it actually looks like a mathematical function. So the only thing is this this image we're looking at now is maybe like 10 milliseconds of audio. There's a lot of like these samples going on. So we need a way to kind of like compress stuff so we can look at a whole minute of audio in one overview. So we can use the Ruby enumerable method for that. We can use each slice to just get slices of data, and then we kind of aggregate those together to create a more comprehensive image. So that's what we're doing here. If you want to check out this code, it's a little complicated. Definitely look at the repository. But then we end up with images like this one. And if you ever work with any digital audio, you're probably familiar with what this one looks like. So this is sort of like our way in. So now we can see some stuff, and then we can start listening to some stuff as well. So the first thing we're going to do is we're going to make some stuff, some audio louder, just to kind of start with the simplest thing we can. So if we take a little waveform, like for example this one. This is a little drum loop. Oh, sorry. So we got a little drum loop here, and we actually want to make it louder. So we want to, if you compare these two images, you'll notice that the peaks are kind of going up. So the higher the peaks are, the louder the audio is going to be. So we got a little higher peaks here, and that sounds like this. Yeah, so it's the same thing, only louder. And how can we achieve this? Well, we just have to multiply all the samples with some kind of other number. So if we want to make the whole thing twice as loud, we can just loop through through all the samples, and multiply them with the ratio, and then rewrite that back to disk, and then we end up with a louder thing. And there is an issue here potentially, because if you multiply it with a ratio where it's actually louder than what the whole range of numbers can be, you get a result like this. So we're getting like a heavily distorted sound now, and audio engineers call that clipping. So it actually cuts off like part of the waveform at the top, and you get this ugly distortion. And you can see that here, that like actually the loudest parts of the signal are actually out of range of the image here at the moment. So they're being cut off, and then because they're all sort of like the same at the top, you end up with this distortion. And that's also the basic principle of how distortion works. So if you like listen to like metal, I guess we're in Finland, so I should talk about metal. If you listen to metal, there will be a lot of distortion, which basically follows this principle, only in a like more aesthetically pleasing way. So the next thing, like you'll hear on every record, is mixing. So mixing sound sources used to be done by kind of like taking electrical currents and kind of mixing those up. But in the digital world, we can do this as well. And what we do then is we take multiple channels, and we kind of combine those into one more complicated waveform. So these are some of the samples we'll be using here. And the way we do that is we simply read all the audio for like this bass, this drum, and this piano track. So we have like 3 samples of the exact same length that start at the same time. And we can make a really little small mixer in Ruby by looping through the first track and then taking like data from the other tracks and just summing that up. So we just simply take like every single number, we add those up together, and then we end up with a mixed result. So this is actually a mixed sound in Ruby. Yeah, so we're doing really almost nothing here, and it just works. And I think that's kind of like the magic of this audio stuff, that if you really get down to it, there's not really much there. While people sometimes pretend there is like a lot of complicated stuff going on. So the next thing we're going to talk about is compression. And compression is a way of making things sound louder by actually making them less loud, which sounds like a paradox, but I will explain that in a minute. That used to be done with like this analog machines as well. So, so if you have a signal like this, and there are some peaks in it, those peaks are actually preventing you from making it louder, because if you would make everything loud, you would get the clipping thing that we just talked about. And you would get distortion. So you actually need to find a way to make these peaks less loud, so that you can sort of like bump up the signal of the whole thing. So the way that works in the audio world is that you pick a threshold, and you only make things that are higher than that threshold. You kind of select out the things that are higher than that threshold. And the next step is to only make those parts of the signal less loud. So you're bringing down those peaks, and once you brought down the peaks, you can like move the whole thing. You can amplify the whole thing again in the second pass. And this is like the basic thing that's used in recordings just to make things sound loud. So if you look at if you listen to something like Daft Punk, they will use this like very intensively to create the effects that they want. And we can also do this in Ruby. So say we have this little piece of audio. It's like a cymbal hit. We can use some Ruby code to do this compression trick. And we actually need 2 steps here. So the first step is identifying samples that are above the threshold, and then we're bringing the volume down. So again, we're looping through the whole track, doing all the samples. And we're selecting, with this if statement, we're selecting the samples that are above this threshold, and then we're just making them a little less loud using this ratio. So that's pass number 1. You know, the peaks are kind of like brought down. And to make the whole thing louder, we're doing the exact same thing that we did before with the amplification. So we're just multiplying all the samples with this extra step. The audio engineers like to call this makeup gain. I'm not exactly sure why, but that's their term. And then we combine those 2 steps to create our compressed sound. And that brings us to, you know, we had this thing. And I believe I have made the worst sounding compressor that exists on the planet, and you will hear it now. It's not pretty. So we're going from this to this, and it sounds like this. So if you might notice like the ringing that goes on. So like the initial hit sounds just about as loud, but then you kind of like get this really long tail end of just like a weird like ringing sound. And maybe I should sell this thing. You know, it could be like it could be a genre in 5 years or 10 or 20. Who knows? So that's sort of like the mixing part of things. So next up, we're going to like dive into like some ways of actually making sounds. So back in the day, and actually now these things still are used on a lot of records. They sound amazing. Like people use these analog synthesizers to make sound, and they had like electrical circuits that can generate waveforms. And nowadays you can obviously also do that with a computer. So there's 3 ways actually in which synthesizers like this make sound, and we're going to like quickly cover those. So the first thing you can do is make noise. And making noise in Ruby is not really hard. You know, you just have to use random. So we're giving the random function a range here, like from minus 30,000 till 30,000. So we're just getting random dots on the whole thing within this range. And the visualization of that looks like this. It's, well, as random as a computer can be. And that sounds like this. Yeah. So that's some real like Ruby generated noise we got there. And you might ask yourself, like, what's the point of like having a synthesizer make noise? And the reason it's in there, or at least what people ended up doing with it, is that it's used for percussive sounds and snare drums a lot. So if you kind of like just cut off and if you kind of like introduce passes within the noise, you sort of like get a percussive sound like this. And then yeah, you got some real like Ruby generated snare drums there. And the next thing a synthesizer can do is generate a square wave. So a square wave is, like as the name implies, a wave that's square. And to make a square wave, we need to create something, we need to replicate something that's called an oscillator. So an oscillator comes from sort of like the electrical, the name comes from the electrical side of things, where like something would generate electrical current in a kind of pattern. So we're doing that in Ruby here. So we create a class, we include the enumerable method, so it's easy to do things with it later. And then we've got the each method at the bottom. So if you create a class, include enumerable, and just have a def each, you can do like all the nice things with it that come with the territory. And what we're doing is we're yielding next sample anytime like the loop is called. So and next sample just returns either like a high or a very low negative number based on the position that it's in at the moment. So we're getting like a number of like 20 thousandths in a row, and then we're getting like a number of minus 20 thousandths in a row. And if we use that oscillator in a loop, then we can generate some sound again. So we can just use each bit index here because we included enumerable, so we can do all the nice stuff with it that comes with that territory. And we're just getting the next values from that oscillator and adding them to the piece of audio that we're creating. And then you end up with something like this. So we've got a whole bunch of like dots at the top, a whole bunch of dots at the bottom, and then you get something that sounds like this. Yeah, it's quite ugly, but it is actually like the foundation of like a lot of electronic music you probably listen to. So they do all kinds of processing with it, which I'm not getting into today. But this is sort of like one of the fundamentals. Another fundamental is the sine wave. So a sine wave is a wave that's a pure sine. So you can make it by using a circle, which we will do in a second. And the sine wave sounds like this. So it's kind of like it has a very distinct sound as well. So the way we make a sine wave is we're creating another oscillator. And in this case, we're actually using the position together with pi to find the position. We're basically emulating what's happening in this visualization here. So we're using the position. We're using pi to get the position of the circle for this given position, and then we get like the next sample that will form the sine wave if we combine it. So a sine wave looks like this. I just already played it. And next up, we can combine some oscillators to create a chord. So a musical chord is a combination of like of sounds with different pitches, and they kind of make up a more pleasing sound together. So if we take these three oscillators and we combine those two with the mixing trick we did earlier, we get something that sounds like this. So this is kind of like playing multiple strings on a guitar, just by adding up those samples. And the visualization of it ends up being like a lot more complex. You can kind of see like this is actually the combination of three different sine waves being merged together. And if you want to get more into that, I think like one super relevant thing that's used in music a lot, and also in a lot of programming, is the Fourier transform. So this person called Fourier came up with a theory that all waves that exist in reality can be recreated by combining multiple sine waves. You can see an example of that here. And if you're like do anything with data analysis or like signal processing, this is like a super relevant thing to look into. It's a bit like the actual math behind it will be a talk in itself, so I'm not covering that today. But it's definitely super interesting to take a look at. And the last thing I have for you today is like doing timbre with a synthesizer. So one way to do that is to create both this sine and this square oscillator that we made earlier and combine those two sounds together. So if we again do the mixing trick, we end up with this weird looking waveform, which sounds like this. Also not very pretty, like I think I'm making some really ugly sounds here today, so sorry about that. But we just made a timbre just by writing some really simple Ruby code. And that's almost what I have for you today. But I think like I see some skeptical faces here in the audience, so I wanted to prove to you all that you can actually make music with this stuff. So I created a cover of, I believe, the best song ever made, and I'm going to play that for you now, and then I'm finished. Thank you.
It's pretty difficult to take the floor after. Guys, please stay with us. Thank you so much. Quite a few questions. Please vote. You'll get answered what you want. The first question here is from Loudness Warrior. Excellent. How do you sidechain your kicks to your bass?
We're using Ruby.
Okay.
I could have made that. Like, well, sidechaining is a thing where you do compression, but you kind of use use the signal from a kick drum, for example. And probably too much detail for this. So Loudness Warrior, come find me at the party.
Yeah, otherwise we go with Motorhead, everything louder than everyone else. Excellent. Are there any common misconceptions about audio or music that annoy you? Is there something that...
I think the primary thing is that like the actual real musicians all pretend that it's like a super esoteric, complicated thing. Well, actually, they all know it's really simple math. They're just like making a really big show out of it, and I guess that kind of annoys me.
Excellent. Yeah. So you don't have to learn how to play guitar. You can make music with Ruby, right? Can we play with vocals with Ruby?
With vocals?
Yep.
Sure. Yeah. You can take the code from this thing and just like apply any do any audio you like.
Excellent. That was from Yara. And from Nora. How are overtones created and or visualized?
Yeah, that would be another like kind of like complicated thing to dive into. So an overtone is when you have like a pitch, and then like in a real world, it will kind of like other things would also vibrate, and that can create like extra pitches on top of that. And you could make it in Ruby, I'm sure. I haven't tried that.
I have to say, this is one of the occasions where I really feel like a talking head, because most of the questions that I'm asking, I have literally no clue. How would you apply attack/release time to your compressor? Excellent question. Thank you.
I intentionally left it out because I actually I wrote a version that does attack and release. So attack and release is where you kind of try to see if the things that are over the threshold are staying over the threshold for a longer time. But it was getting so complicated that I decided to just not do it.
Have you tried Sonic PI, and what do you think is the future of music in Ruby?
Yeah, so there's this program called Sonic Pi, which is really cool. It's you can use that to like make actual songs in Ruby with using loops, and it's an amazing piece of software. Definitely try that out. And I've tried it a little bit. It's really amazing.
And question from the same person called Anonymous. how would you write tests for it?
No comment.
Thijs, keeping it, respecting the schedule, and also we're heading to lunch in a bit. Thijs, thank you so much.
Yeah, thank you. Yeah. Yeah. Thank you.
So just a few housekeeping things before we move to the lunch. All of you, maybe not all of you, but most, have got a lunch ticket. So there will be lunch for everybody, but this is, the different colors are different venues, and well, obviously you figured out, it's to split the load. So second floor is, all other floors are omnivores, lots of food. If you have a special diet, then that is second floor. And please use the same lunch area tomorrow. And then the question, but if all of my friends are going to X, Y, or Z, of course you can go. But for most parts, please stick to your chosen lunch area. What else at this point? Whoop-de-doo, it's 1 minute to 12. We will start at 1 p.m. sharp. Must be present to win. Enjoy your lunch. So happy that you're here. See you soon.
2 minutes, we will continue with today's program. Thank you. So everybody got a good lunch? Excellent. At least I noticed that most people found a place to eat, no matter what your meal ticket said, but you got something to eat. And, at least the discussions I had, people found it delicious, so happy to hear. I'm making marks. There's no line to the water station, coffee station. I think we're ready. Obviously, after lunch, people are still joining us, and that's a great thing. However, at this point, we will move on. Our next talk, discover how to approach CI/CD with an SRE mindset. Learn what SLOs, SLIs, and error budgets are, and how to define them for your own build and deploy processes. Rebuild trust with your system's stakeholders, and reclaim control over slow and unreliable build and deploy processes. So, applying SRE principles to CI/CD, and with a nice, great big applause, let's welcome Mel Kaulfuss.
Thank you. Here we are. I hope everyone enjoyed lunch. Oh, whoa. Let's get this party started. Oh no, the sound didn't work. There was a sound, and I really wanted to play that. Aww. There it is. The party hasn't started if we haven't heard the Mac sound from the 2000s. Yeah. So my name's Mel. I'm a lead developer advocate at BuildKite, and I come from Melbourne, Australia. BuildKite is a CI/CD platform. It has a hybrid model. It means you can run our build agents on your own infrastructure, and we host and maintain APIs and a UI so that you can see all your pipeline and build-related information. Now, it's not a competition, but I think I probably flew the furthest to get here today, and I'm willing to have discussion with anyone who thinks they flew further, but my flight was 25 hours. Yes. I know someone that caught a ferry from Germany that took 30 hours, so they win in the duration stakes, but not the distance stakes. And I have my flashlight on my phone on, and that's really amateur. So, I love Ruby. I love the Ruby community. Just a bit of background. I wrote my first line of Ruby, or any code at all, at a Rails Girls in Melbourne in 2014. And from then, yes, shout out to Rails Girls. And since then, I attended my first Ruby conference, and I looked around and I met a whole heap of people, and I was like, I found my people. Like, for the first time ever, the Ruby community welcomed me, and I was part of that. And from then I went on to organise 3 Ruby Conps in Australia and to have emceed 4. And I can't believe I'm at Euruko, and this is the first time I've travelled internationally since 2020, so it's a big moment. And I'm going to just take a selfie to prove to my workplace that I'm not just here on holiday. I'm actually working. So there you go. Thank you for that. So today we're going to look at CI/CD through an SRE lens. I will cover some of the issues we might face in CI/CD, and we'll take a look at some of the SRE principles and how we might apply them to CI/CD in a practical sense. Am I making that microphone? I think it's my hair. It's designed for men with short hair, sorry. And today's drama, it's really a beautiful venue to unfold this story. It's a drama that will happen in 3 parts. We'll have a drama, we will start to pull ourselves up out of the rabbit hole, and we will look to a rosy future together. So let's get into it. If there's not drama, we aren't shipping software. Would you agree? There's always drama in what we do. So let's set the scene. I don't have a dramatic score to play, but you can imagine whatever music you would like. Something dramatic, Game of Thrones, Lord of the Rings, that sort of thing. I have Game of Thrones. So we have a monolithic code base. We have a gargantuan test suite. And for some additional drama, we have microservices for as far as the eye can see. That's the software landscape we operate in 2022, and it's complex and very, very difficult to navigate. But I'm probably like you. We all love a good challenge. That's why we work in tech. We love the highs, we love the lows. And it's not about the destination, it's about the friends we make along the way. And friends, today is a big day for me. My adventure is coming to a conclusion. I am about to ship a thing that I've been working on for a couple of months. I'm pretty excited. It's been tested. It's verified. We are ready to go. The branch is green. We're going to go to Maine. This is a big moment. And I've always wanted to say this, make it so. So, my build's kicked off. I've got time for a coffee. I'll enjoy some freshly brewed vibes with some freshly shipped vibes. My day is looking good. But my day is no longer looking good because my build failed. So sifting through the logs, I can see that a test has failed, which is weird because everything on my branch passed. The test that failed isn't even related to the code that I just shipped. So, FML. I'm blocked, pretty blocked, headed down the rabbit hole that I just don't really like going down. So I don't know how you all feel about CI/CD, but I mean, I love CI/CD and I work for a company that builds CI/CD, so clearly I love it. But as a software developer, I'm pretty partial to not knowing, like not caring or wanting to know that CI/CD exists. I'm like, you stay over there and you do your thing. I will stay over here and do my thing. I want to push changes. I want to know that my code is tested and that it's safe, and I know that it'll be live within, 10 minutes in production, even on a Friday. I don't think that's too much to ask. Do you? Apparently it is. And we end up not trusting CI/CD like we should be able to, and we end up battling the system, we end up adapting workflows to sort of processes that just don't live up to what they're supposed to or what they say on the tin. And like it says on the label, continuous integration and deployment is the automation of building and testing code. CI/CD allows teams to ship code easily and frequently with a high level of trust that users won't be impacted by bugs. Not today. So at least at BuildKite, we have a retry failed step button. So that means I don't have to kick off my entire build again, but I'm mashing the button. And the same test keeps failing and failing and failing over and over again. And I just want to get my changes out. Yeah. So flaky tests are a thing. I'm pretty sure you know they're a thing. I know they're a thing because when I searched in Google for like flaky test memes, there were literally thousands. So I think when we encounter a flaky test as software engineers, what we do is we go make a meme. And I think that's great because it gave me lots of material to choose for my talk, so thank you. But yeah, like, I remember when I first started working as a software engineer, I pushed a build. It was like a tiny change, like tiny. It was like baby steps. And the build was red. And I turned to the senior engineer next to me and I'm like, for some reason this test failed and it doesn't seem related to what I just pushed. And it was a smoke test. And he's like, oh, that never worked. And I'm like, okay, cool. I wonder why we still do it then. That's weird. But from that moment on, I was always asking. It was never my code's fault. Every time there was a failure, I'd be like, surely that's a flaky. Yeah, that's got to be a flaky. Nothing to do with my work. But yeah. Whoops. I didn't mean to skip ahead. Sorry about that. So yeah, we need to be able to trust our tests. Like, as software engineers, we want CI/CD to provide us with fast, reliable feedback about the software delivering. And when it doesn't, I think we have some problems, and so do the end users of our systems as well, because we no longer trust the system that we've put in place to ensure what we're deploying is safe. And last year, what is going on? Last year I did some digging into the impact of flaky tests on our users, and I like going down rabbit holes when I choose to, so this was one of those rabbit holes. I'm like, hey, can someone run me a query to find out how long users spent hitting the retry button? And I was pretty staggered to see these numbers, the very real monetary cost that retrying tests had on BuildKite's users. And so over a 1 month period, just let this sink in. Over a 1 month period, BuildKite users spent a cumulative 9,413 days hitting retry, which is a huge, huge number. And if you think about that across multiple, Circle CI, all the CIs, that's a lot of cost. If you think about the environmental cost, if you think about the monetary cost of developers sitting there hitting retry, it's a big number. And to use a Martian for scale, you can get to Mars and back 17 times in 9,413 days. So it's a big number, big cost. And besides the time I've spent sitting there hitting retry to see if my build passes or fails, I've lost my flow. And what do we do when we lose our flow? We go into Slack. We've got to get rid of all the little white dots, the unread notifications. We jump into Twitter, dump a hot take or two, back out. But it takes time to get back into the zone. And I'm sitting there, and it's also disheartening to have to ask in Slack, does anyone know if this test is flaky? I'm sure I've seen that fail before. Sometimes it passes, sometimes it fails. And if I'm also battling mega slow builds, it's like, I just want to get my changes out. So I don't really need to go on, you get the picture. I'm sure you've all been where I've been right now. It's quite frankly a shitty place to be. But let's look at how to get out of this awful place. So how can we minimize the impact of situations that I have just vividly and realistically lived through for you today? Turns out SREs know a thing or two about ensuring that systems are reliable. Just a little bit of a history lesson. The first SRE team was formed in Google in 2003. They wrote a book called Site Reliability Engineering and How Google Runs Production Systems. It's a very, very good book, lays out some of the principles and practices of SRE and the benefits of this approach to maintaining services and associated infrastructure. There's a lizard on the cover, and I actually thought it was a monitor, but it turns out it's a lizard, and I think it's a very big missed opportunity that Google I don't know how they let that one pass. Wouldn't you use a monitor for a site reliability engineering book and not a lizard? But regardless of what you think about the choice of animal, you can read this online for free. So you don't have to give them your money if you're disgusted that they didn't use a monitor and that they used a lizard. So we can't talk about SRE without talking about DevOps first. And in Google's SRE book, DevOps is defined as a loose set of practices, guidelines, and a culture designed to break down silos in software engineering, operations, networking, and security. And that's it in a nutshell, really. DevOps principles encourages us to remove silos and do away with any barriers that exist, either organizational or between the different disciplines in teams. It encourages us to accept that accidents are a normal part of building and maintaining software. And they also encourage us to embrace gradual change, and naturally CI/CD plays a big role in that principle. And understanding that tooling and culture are interrelated. Tooling and automation are, of course, a very important part of DevOps, but DevOps thinking understands that the organizational culture and human systems and processes are really the key to adopting new ways of working and are far more critical to success than tooling alone could ever be. And finally, Google's SRE handbook states that DevOps thinking understands measurement is crucial for success. It's crucial to breaking down silos, to managing production incidents, and it's also essential to clearly and objectively measure and verify reality, which is a really great thing to have in place. So DevOps is essentially a philosophy. It's a way of thinking about our work, our people, and our organizations as an ecosystem and keeping it healthy and functional. An SRE, on the other hand, is more practical. It's about improving operational practices, efficiency, and as the name suggests, the reliability of our core systems. And that sounds good to me, because I don't know about you, but I want CI/CD to be reliable. So there's many examples of SRE principles out there. There's no real definitive list set in stone, but there's a couple of common characteristics that are included in any definition. And that is that we work towards automation or elimination of anything repetitive, and especially when that's going to reduce costs. We will have system design with a bias toward reduction of risks to availability, latency, and efficiency. And that we should have the ability to ask arbitrary questions about our system without needing to know ahead of time what we would like to ask. And this is my favourite, avoiding more reliability than what is strictly necessary. Now, whilst SRE focuses on reliable services, 100% reliability is never the goal because we know that's unattainable and we accept mistakes are part of software, so we will be okay with that. And SRE seeks to ensure that systems are as only reliable as strictly necessary, and defining what is necessary is actually a practice unto itself. So thanks for being in this little SRE-shaped rabbit hole with me. It's been lovely. It's probably time to get out though, because there's people wanting me to ship this feature. So Mercury isn't in retrograde at the moment, so it's definitely not that that's bumming me out. We do have problems. We know we've had problems for a while. They keep cropping up when we least want them to. But how do we begin to address the problems that we're having? So we all just heard about SRE. Let's look at putting some of these principles into practice. So things are bad. Like, I think we can all agree they feel really, really bad. And we know we have a problem with flaky tests. We're pretty sad about how slow our builds are and how long we even need to wait for a build to kick off. So we know it feels bad, but what do we actually know? Remember that, oops, did I skip? I did. Oh, sorry. Damn, I can't work this computer. Remember DevOps thinking and SRE principles both say that measurement is crucial for success and that we need to practice observability and have ready access to data and information about our systems. Well, that's what we're going to do. We need good metrics as an objective foundation for conversations with people who will all agree upon them. And they will be able to agree on them because we will have some hard facts about the state of our system, not just some feels. And that all sounds pretty good, but how does it work in practice? Let's take a look. So I think we can all agree with this statement that it's impossible to do your job well if you haven't defined what well is. How do you improve things if you don't know how bad they are to start with? So site reliability engineering uses SLOs, SLIs, and error budgets to do this. They use them to define what's important and how reliable things should be, and also how to measure these things and goals and how they're tracking. And when these things are clearly understood and defined like this, it's almost magical how well it allows teams to focus their energy and efforts on the things that matter. So what's an SLI? It's a key metric to indicate whether an SLO is being met. An SLO is a promise that's made in relation to a metric that matters to users or maintainers of a system. So where an SLO defines a level of unreliability that's acceptable, the error budget reflects how much and for how long the service in question can fail to meet the SLO before there's consequences. Now, how do we get everyone to agree on what SLOs, SLIs, and error budgets to set? I'm glad you asked. I'm going to guess that if you're feeling pain right now, others are probably feeling the same pain as well. And that's the perfect time to come together and start working to improve things. We're going to stop being reactive and we're going to be proactive. We're going to assign metrics and we're going to strive to uphold them, but only when we need to, and it's going to be amazing. So it's time to ask some questions. So get together in a room, in a Zoom, get together and start building a picture, take stock, get on the same page. What is the system in question? Which system are you talking about? Are you talking about CI/CD? Are you limiting the scope to an application's test suite? Is it its speed, its reliability? Who are the system stakeholders? Who relies on the system? Who maintains it? What is important to all these different stakeholders? What is working for them? What isn't? working for them. The quest is to understand what everyone expects from the system, which may differ, but it's important to understand what people expect. So once you have this shared understanding, it's time to agree on some SLOs, SLIs, and some very reasonable error budgets. You might want to stop developers waiting around for builds to kick off. So a reasonable SLO could be that builds should start running within 30 seconds. For this, your SLI might be the time spent waiting for a build to start. That would be the metric that you collect. Your error budget might have 33 builds that take more than 30 seconds to start running over a 4-week period. Just quickly, Google's SRE book suggests there's a method to calculate what your error budget is, and that is 1 minus your SLO percentage. They use availability and uptime as their percentage, so it's a little bit easier to use this calculation, but you know, it's important to remember that error budgets are flexible. You know, that's something you can work on together. But if you want to look up this, you can just Google how to set an error budget, and there's a bunch of information out there on that. You might commit to developers having commits and tested and notified of success or failure in 5 minutes. For this one, your SLI would be total build runtime, and your error budget might have 33 builds that finish in more than 5 minutes in a 4-week period. And when it comes to my problem today, a great SLO would be that my test suite should have a reliability percentage of greater than 87%. And your error budget might have 77 test runs, the suite runs with a reliability score of under 87%. And once there's been more than 77 test runs under 87%, the budget is gone, it's spent. So how do you get all these SLI metrics? That's a good question. When it comes to production monitoring systems, there's Datadog and Honeycomb, they're the big players, but there's heaps of other services that allow you to configure metrics, custom metrics. Honeycomb even have a product specifically for managing SLOs along with their observability tooling. For total wait time, it's possible that your CI/CD will have a way to access this metric. We have a CLI tool for collecting BuildKite agent metrics with this AWS CloudWatch, StatsD, Prometheus, Stackdriver, all those things. And we also have open telemetry instrumentation now built in the agent, so you can send traces and metrics around build wait time to services like Datadog, Honeycomb, things like that. So once you have that SLO being measured via a particular SLI, you can start tuning your agent capacity as the need arises and start reducing that total build start time. You want developers to have speedy feedback loops. Your SLI for this would be total build run time, and we have an API endpoint to collect this data. And our UI also has a monthly average build time visible for each pipeline, and your CI/CD should probably have this data as well. So once again, once you're measuring this build runtime metric, you can start tuning your CI/CD infrastructure and pipelines as you need to, only once you've spent the error budget, of course. Let's just imagine you have nothing left in the budget. You've had more than 33 builds that take longer than 5 minutes. So you've got to get those times back down into the acceptable parameters. So because BuildKite agents are hosted on your own infrastructure, you can leverage the same cloud-hosted capabilities like the auto-scaling compute capabilities as you would for your production infrastructure, and pipeline steps can be also optimized to run in parallel across as many agents as you need to. So that really speeds up builds. Unfortunately, it doesn't look like Speedy Kitty. It looks like that, which is much more boring. I submitted a ticket to engineering, and they're not going for the Speedy Kitty look. They're going to keep it the other way. I don't think I agree, but yes. Another method to speed up builds is to look at the performance of your tests. So we have a new brand new shiny product called BuildKite Test Analytics, and you can access a whole host of interesting information about your test suite health. You can track down slowest tests and you can optimize them. You can sort by the slowest test, for example. And in this example here, we sped up a single test that formerly ran in 35 seconds, and now it runs in under 3 seconds, and that was just by switching out the capybara matcher that was used. So it was, if you think about a 27, I can't do maths up here, 32-second speed gain on a single test, like that is a lot over an entire suite. So there's a lot of performance gains to be had in that. But once you've defined what's important, and once you understand what stakeholders think is important, you can access those metrics and you can tune performance as you need to. And again, this was my problem today, and this SLO is like on the money. And if we look at the suite reliability score, it's like super low, so there's work to do. And that metric is front and center in test analytics, and you can see a reliability percentage over time. And once the error budget's been depleted, you can sort individual tests by the least reliable. Each test also has its own reliability score, which is pretty interesting. And we've just, like last week, released a prototype feature, so it's still being like early beta tested, where it gathers a list of 100% definitively identified flaky tests that like you can see in the list, and then you can whittle them away as you need to. And there's going to be an API for that at some point as well. But yes, test analytics is a pretty big game changer for RSpec suites. There's also a mini test collector, but it's not as fully featured as the RSpec one because we use RSpec at BuildKite, so naturally we built it for our own needs as well as other people's needs. One important thing is that you don't need to use BuildKite for your CI/CD to use the test analytics. You can use it with GitHub Actions, Circle CI, all the things. It's just a gem that you include if you've got an RSpec test suite. So it's pretty neat. I encourage you to check it out. So it's both horrifying and amazing that we have ready access to the metrics we need. It's horrifying because we know how bad things really are, and it's amazing because we're in a position to really improve things now. It turns out the test that failed earlier was flaky. I guess that's no surprise to anyone here. My battery's running low. That's amazing. I really need to finish this before my computer dies. I don't have a power pack. Help. I know it's flaky. I can quarantine the test now, and then I can get on with doing what I have to. Error budgets, though, what a gift to focus. We can spend, and while we're in the money, it means we don't have to drop everything to fix things, right? If the test is flaky, we can just keep working until we've spent our error budget. They basically exist so we can maintain momentum and focus on our work, and it's once that budget's gone, that's when you need to broker an agreement on what happens next. The concept of downing tools to fix a system once an error budget isn't met can be a huge point of contention when implementing SLOs and SLIs, and the hardest thing of all for some people. Ideally, you'll halt feature development and you'll get your SLO back being met, and then you'll resume feature development, and that, as we all know, is contentious. It's not easy. It's not an easy path to get everyone on board with this method, but I think you'll understand that as developers, like actually maintaining your system and like working on technical debt, reducing that, like is a really important, hard thing to prioritize. But if you have these metrics and these hard facts, it's an easy thing to start prioritizing. So it might be drastic. It's important to remember that this is all a journey. They can be tweaked as needed to keep everybody in your organization happy, but it has a massive payoff. I will leave you with this quote by Charity Majors about SLOs, that they're a powerful weapon to wield against micromanagers, meddlers, and feature-hungry PMs. They're an API for your engineering team. And I believe that's it. That's the talk. Thanks for being there. I'm so glad my battery didn't die. This is amazing. Oh, my God. We have a virtual booth. You can sign up to find out more about BuildKite. There's also some resources, some webinars and things that are linked to in there. You could follow us on Twitter, and you should come and say hello. I have some stickers that are like based on this retro vibe, which are really cool. So, and I also have 10 BuildKite kites that I would love to give out, because I don't want to take them home to Australia. So come and harass me for a kite. That would be cool. Enjoy the rest of the conference. Thank you.
Excellent. Thank you, Mel. We have a few questions.
Go for it.
Would you be happy to answer those at this point?
Thank you for asking. I would love to answer.
Excellent. Any tips on strategies to fix flaky specs?
Well, yeah, that's a hard one. They're all pretty different. In my experience, they're always integration tests, and it's always about a pixel not being where you expect it and a button not being there. I mean, that's hard graft. I would probably pair with someone on that one.
How do you differentiate between tests that fail because the code is wrong and flaky tests and other infrastructure problems?
Well, I'm glad you asked. Yeah, I had the same problem when I was a software engineer before I worked at BuildKite and understood all this. I would usually, my first port of call would be going to the systems engineer and blaming them for some infrastructure change, which wasn't the case. It's usually my work. But that's hard. I think giving test analytics a go, I don't want this to seem like a product plug, because it's not, because you can use it for free. That actually is a game changer, because like once we release that like thing that's in prototype now, you will be able to get a list of 100% flaky tests, which I think is amazing. Currently, you can see like a percentage of reliability score. And so you can sort of see on the graph, it's green, 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 red. And then you look at the commit that's associated and you're like, that doesn't seem like it even corresponds. I think that's flaky, but like soon you'll be able to say that is actually flaky. Yes.
Excellent. You mentioned CI reliability score. How do you define that score?
The CI reliability score. I think that was the test suite reliability score, maybe.
Gotcha.
Well, there's just a number in the test analytics.
There's a question from Schwad. If a team is reluctant to introduce SLOs, SLIs, could you first SLO be set to match your current system in order to identify and prevent further regressions? That's
a great strategy. Yeah, sure. I actually think even answering that question is like having some information that you didn't have before. So I think it's a great start. Yeah, and then you can be like, I'm feeling brave. Let's like bring that number down or up or whichever way it is. Yes.
From Harrison, we have a question. Is it better to increase SLO after continued success or focus on consistency?
That's a question for you. I don't know. I'd probably be pragmatic and just keep it like, as in, if you've had the discussion with all the stakeholders of the system and they're happy with what it's currently operating at, keep it as is, focus on something else. There's always something. Our work is never done, right?
Excellent. Quite a few questions regarding, can you post the awesome slides online somewhere?
Yeah, sure.
Excellent. Mel Kaulfuss.
Thank you.
What I really appreciate by the organizers, we have
build in some room to the schedule. So here's 10 minutes. Have a chat, grab a coffee. We'll be back in 10 minutes, 10 to. See you in a bit. the water cooler metric tells me that we're good to go. After the firecrackers of getting pop culture in and out, let's go to now something totally different. Object shapes are a technique for representing objects' properties that can increase cache hits in instance variable lookups, decrease runtime checks, and improve JIT performance. In this talk, we'll learn how they work, why you implement them, and interesting implementation details. The next talk, Implementing Object Shapes in CRuby by Jemma Issroff. Woo! Da 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 da. Jemma just told me that she never had an opening song, so it's the first time now.
We were talking about walk-up music. I was saying I'm not used to having a whole walk-up set, but that was it. So many of us might be familiar with the announcement that looks something like this. We're used to seeing it every year when a new version of Ruby is released. And as Matz was talking about in his keynote this morning, this year's version is going to be Ruby 3.2. And we'll get an announcement that looks something like this again. It comes out every year on Christmas, so the date will be slightly updated. And maybe some parts of the announcement will also be updated. And pulling together these slides was actually the first time I noticed that Ruby is all of our best friends. I don't know if anyone else had seen this before. But with this announcement comes a whole new set of features, right? With each Ruby version, we have new features. And we might be used to from our own development when we ship kind of new version releases or new application versions. We have a whole bunch of features that we're shipping to. And some of them are really visible to the end user, and others aren't, right? Others are more of performance improvements or security improvements or things like that. And similarly, each year when we ship a new version of Ruby, we have some features that are really visible to the end user, right? Some totally new features, maybe pattern matching or reactors or something like that. And other improvements that are more behind the scenes, right? Security improvements or performance improvements or things like that, which will make our experience better, but we might not necessarily notice or interact with in the exact same way. And what we're going to talk about today is something that's going to fall into this latter category. So I've been working for the past few months alongside Aaron Patterson on implementing a technique called object shapes in CRuby. And it'll ship with Ruby 3.2, right? It'll be there behind the scenes, but it's not going to be something we're going to see in the same way we might see pattern matching or see something like that. But we'll still go into exactly what it means, how it's going to impact performance, and the kind of behind-the-scenes look of what object shapes are. I'm Jemma. If I haven't met you yet, I would really love to. I work at Shopify on the Ruby and Rails infrastructure team, and that's where I've been able to do this work. And over the course of today's talk, we're going to answer these three main questions. So first, we'll talk about what object shapes are. Then we'll go into how they're implemented. And then lastly, we'll talk about the benefits of object shapes. So why implement them? Why did we make this change? So first, to begin with, what are object shapes? Well, when we think of object shapes, we might think of a diamond or a triangle or an oval. But this is not what we're going to be talking about today. We're not talking about literal shapes. When we say object shapes, when we say object, what we really mean here, what we're referring to, are Ruby objects, right, that we're quite familiar with, an object.new or something like that. And when we say shapes, it's kind of in these quotation marks. It's not literal shapes. It's a name of this technique that's been around actually since Smalltalk. And so each Ruby object, we're going to say, has a shape. And the shape represents the object's properties. So what are some examples of properties? Well, something like the frozen status, whether or not the object is frozen, or instance variables on the object, so we can access its instance variables. And when we talk about this, the reason we want a representation of the object's properties is because Ruby is a dynamic language. So there's some languages like Java where we'll know all the information about an object up front, but in languages like Ruby, this can change through the course of running our application, right? We can add more instance variables to an object or freeze it or do things like that. And its properties and the shape of it will change. And so we can use this concept of a shape to say, hey, this is going to represent all of the properties. And we'll dig a little more into what that means. So we're going to begin by looking at this example. We have a class post with a title and an author, and we're going to create an instance of this class post. And we'll look at its shape. Again, the circle is nothing to do with an actual circle, just to hold the information we're about to talk about. So the first thing the shape of this first post is going to have is the instance variables. So we see we have two instance variables, the title and the author. And those will be our instance variables on the shape. And the next thing the shape is going to have is a frozen status. So if we were to freeze first post, the frozen status on this shape is going to be true. And shapes have IDs, which uniquely identify them. So the ID of this shape, let's arbitrarily say, is 6. OK, so that was one example. Let's walk through another example. We have this user class. Similarly, we have an instance of it. We know its instance variables are these name and login instance variables. Those are the ivars on the shape. And we'll give it, again, arbitrarily the ID of 31. If we have this separate class admin, which is very similar, you'll see it has the exact same instance variables, but it's separate to user, what's going to happen in this case? So we have our instance of admin, and we can see it has those two instance variables, name and login. But these two shapes have the same properties. And so what happens if they have the same properties? Well, they're actually the same shape. And this is a critical point, that these two instances of different classes can share the exact same shape. And we said a shape of an object transitions with new properties. So let's look at how those transitions actually happen when we add new properties to a shape. Everything starts at what we call the root shape, which has an ID of 0 and no instance variables on it. It's practically empty. And so when we initialize first post, when we first call post.new, we'll start at this root shape. Then when we set the title to this very creative title, we'll transition through an edge named title to a new shape. And that shape's going to have ivars just title and the next ID. And we'll make that transition. And then similarly, when we set author, we'll transition again through the instance variable author to a new shape with instance variables title and author and the next ID. And we'll make that transition. But if we had this post class split into two methods where we set the title in initialize, but then we set author in a different set author method, well, we know then first post would have this shape with ID 1, right? Because it just would have the instance variable title. But what if we had a second post, and on that second post we called set author? Second post would have a shape with ID 2, whereas first post had a shape with ID 1. So this is another critical point here. Two instances of the same class can, as we're seeing on this example, have different shapes. OK, to look at another class here, say we have an image, which also has a title. But instead of an author, it's going to have an image URL on it. We know by now when we call image.new, we'll start at the root shape. We'll transition through this edge with name title to the shape with ID 1. And then we're not going to take the same author transition. Instead, when we set image URL, we'll make a new transition to a new shape. And the instance variables on this shape are going to be title and image URL. And it'll have the next ID, and we'll make this transition. And you'll notice the shapes form a tree. If we were to run some version of the snippets we've had so far into Ruby code, we'll see a tree that looks something like this. And we're going to get more into specifically what's going on here and what everything means. But when we were saying the shape of an object transitions with new properties, and we were saying the frozen status can be one of those properties, let's look at what that would mean on our shape tree. So say we have an anonymous post, anonymous because it only has a title and no author. And we had an instance of anonymous post. We would start at the shape with ID 0. We would transition through our title to the shape with ID 1. And then say we were to freeze our anonymous post. We're now at the shape with ID 1. We're not going to take the existing transitions. We're going to instead transition through a frozen edge to a new shape. It's still only going to have the instance variable title, but it'll also be a frozen shape. OK, so that was an overview of what object shapes are. The next thing we're going to discuss is how we implemented them. So a little behind the scenes of the implementation details itself. That'll allow us to then talk about what the benefits are. Why did we implement them? So first, how do we identify shapes? And we'll get to, again, more of the specifics on this tree momentarily. But we can see here we have IDs on each shape. So each shape has a unique identifier, a unique ID that's going to say, hey, this shape with this ID has exactly these properties. And we have room for quite a few different shapes. So we can run Ruby on 2 different types of machines, on 64-bit machines and on 32-bit machines. Most of the time, we're running on 64 bits. All of your production applications, I hope, are running on 64-bit machines. And on 64-bit machines, we can use 32 bits for shape IDs. 2 to the 32 is going to give us about 4.2 billion shapes. On 32-bit machines, which are much less common, although WASM, which Matz was talking about, runs on 32-bit machines, we use 16 bits for shape IDs. And 2 to the 16th is about 65,000 shapes that we'll have on 32-bit machines. And just to contextualize these numbers, so on Rails Bench, which is a benchmarking suite for Rails applications, we have about 10,000 shapes. I also ran object shapes on Shopify's Monolith, which has got to be one of the biggest Ruby applications out there, on the test suite, and it was 40,000 shapes. So both of these would comfortably fit within 32-bit machines and will definitely fit within the 4.2 billion shape threshold. OK, so the next question we might have is, what information is encoded within a shape, right? I've alluded to these properties. What's really going on here? Ruby, as some of us might know, is written in C. And so we have this RB-shaped struct. And it has a few different properties on it. And we'll walk through what each one means using our shape tree diagram from before. So to begin with edges, an ID table is basically a hash or a map from keys of some value to values of different value. So we'll start, say we're looking at shape with ID 5. We can see it's going to have those 2 red arrows will be the two edges out. The keys are going to be the values, they're login and frozen, and the values are the shapes. So it's telling us which edges exist on a shape. The next is the edge name coming into the shape. So again, if we look at this shape with ID 5, the edge name, or that property transition, was name. Next up is the instance variable count. So how many instance variables are on this shape we store, and we'll see in a bit how this comes in handy. And you can see here the number of instance variables we have on these shapes, 2 on shape with ID 2, and also 2 on shape with ID 6. The next thing we have on a shape is its type. And shapes can be 4 different types. We'll go through what each one means. So to begin with, we have the root shape, which we've already discussed. Is this empty shape at the beginning. All objects start at this root shape, right? Because at birth, they have no properties on them. Next are IVAR shapes. So all of these other black shapes in this diagram are IVAR shapes. And what that means is that they've taken an instance variable transition. So they were created through instance variables. Next are frozen shapes. So the two blue shapes here are frozen. And you'll notice that they're leaf nodes, right? And this, if we think about it, makes sense, because we know if an object is frozen, we're not going to set any more instance variables on it. So we're not going to make other transitions to other types of shapes. And another thing you might notice is they both have these frozen transitions leading into them, right? To get a frozen shape, we must have made a frozen transition. The next type of shape is what we call this undef or undefined shape. And it's quite an interesting case. It's this orange or yellow shape at the end with ID 4. And you might have noticed we have title twice here, right? We had two title transitions to get to this undef shape, which doesn't really make sense given what I've already said, right? If we have one instance variable, instance variables uniquely dictate a shape. So how did this happen? How could we transition to this undef shape, and what is it saying? Well, to go back to our post class, let's say we have a post, an instance of post, first post, and we set the title on it. We know now we'll make this transition from the top shape, from the root shape with ID 0, through title, to this shape with ID 1. But then something we can do in Ruby, again, since it's dynamic, is we can remove the instance variable. We can say, actually, we didn't want this title thing. And what's going to happen here is our shape will transition through that same instance variable to a shape with an undefined type. And we'll see in a bit where that comes in handy and how that's actually going to allow us to reduce code complexity overall. And the last thing we have on a shape is a parent ID. So this shape with ID 5 that we've been looking at, its parent has ID 0, so we'll store that also on the shape through this edge. So we've talked now about what object shapes are and about how they're implemented. And the kind of most important part of this talk is why. Why did we implement object shapes? So we'll go through several different benefits of object shapes. We'll go through each of these one by one. So the first is increased cache hits. Right? We know caching is a good thing. We know that by default, and we know if we can add more cache hits, that's going to be a good thing. But let's look at specifically how that happens. So with object shapes, we changed how caching works on instance variable reads and writes. So every time you set or you access an instance variable, that's going to work slightly differently in Ruby 3.2 than it did in any prior version of Ruby. But to understand the change, we first want to understand how it works today, right? How this works in Ruby 3.1. So if we go back to our post class and we have our first post, where are these instance variables actually stored, right? When we're setting instance variables, Ruby or something must be keeping the values somewhere because we know we can access them, right? So how is this actually happening? Well, what happens behind the scenes is each instance of a class, each instance has its own instance variable array where it stores the values of all of its instance variables. And then Ruby gives us per class this map of instance variable names to what index they appear in the array. And we'll walk step by step through how this works. So when we set title to the string A, Ruby's going to say, hey, we're trying to set title on this post class. Does it exist in this instance variable names map? No. Let's put it in here at the next available index, which is 0. And then at index 0 in our specific instance of our specific first post instance variable array, we'll put that value. So that's where we're going to store the value of the instance variables. To walk through it again, when we set the author, what we're going to do is say, hey, have we seen author before on a post? We'll say no. We'll put it into this map, into this hash, at the next available index. And then at that index, we'll write in the value b here. I don't know anyone named b, but maybe they exist. And so the one thing you might have noticed here is that we're going to have to do a hash lookup over and over again. And it's not the most expensive operation, but it's also not cheap. And we know when things aren't cheap, the solution there is to cache them, right? So instead of having a hash title over and over again, we can cache this lookup. And what we're going to use as our class key, as our cache key, is the class. This is what Ruby 3.1 already does today. So it says, hey, when we set title on the post class, the index that we were looking at was index 0, and we cache this. And similarly, when we set author on the post class, this index was 1, and we cache this as well. And this is great in most cases, but what happens if we have something like this? Front page post inherits from post. And we have an instance of front page post. Well, now the class is going to be different, but the initialize method is exactly the same. And so we're gonna have cache misses, right? Because instead of having the class post, we have the class front page post. And these cache misses can be costly. OK, so that's the current state of how it works today. What are object shapes changing, or what's different here? Well, we no longer are class dependent in the same way. So we actually get rid of this map from instance variable name to index overall. And instead, we replace it with our shape tree, which should look familiar by now. And we'll see now how all of the things we've talked about before can come into action, into practice, with this cache lookup. So if we were, for example, so what we can do is remember the IV count from earlier is going to tell us how many instance variables we have. We can use that to get the index, right? We don't have to store the index in the same way because it's going to be just the IV count minus 1, right? We're 0 indexed here, so we subtract 1 from the IV count, and that'll give us the index. And instead of using the class as the cache key, we can use the shape ID as the cache key. And you might be able to see how this is going to lead to more cache hits and fewer cache misses. So to walk through concretely the example again, when we set the title instance variable, what we're going to do is our object is starting at this root shape. It's going to transition through title to this shape with ID 1. We know the IV count is 1 here, so our index is 0. And at index 0, we'll then fill in our value. And then what we're going to cache here is, hey, shape with ID 1 has index 0. And again, the ID is coming directly from the shape we're on. And the index is the IV count minus 1. And it's referring to where it is in this instance variable array. Similarly, when we set author, we're going to start at the shape with ID 1 that we were just on. We'll make that transition through the author edge to a shape with ID 2. IV count is 2, so we know that means our index is 1. And at index 1, we're going to put our value b right here. And then we can cache, hey, shape with ID 2 has index 1 in our instance variable array. And we can see the shape is coming right from this shape ID. The index is the IV count minus 1, and it's referring to exactly this point. And now, if we have our front page post, because we're no longer class dependent, but instead our cache is based on the shape, we know we'll make those exact same shape transitions in the initialize method. And so where we previously had cache misses, we'll now have cache hits, which is going to give us increased cache hits overall. The second benefit of object shapes is decreased code complexity. And there are quite a few ways in which we've decreased code complexity, but we're going to talk about 2 specifically. The first is reduced frozen checks in instance variable setting. So this is some pseudocode of before object shapes, so in Ruby 3.1, how setting an instance variable is working. It's going to take 4 arguments to set an instance variable. The object we're setting the instance variable on, the cache, which we just discussed, the instance variable name, so what instance variable are we setting, and lastly, what value are we setting it to. And the first thing we'll do, as we've talked about, is check if the object is frozen, right? We know we can't set an instance variable on a frozen object. Let's check right away. Then we'll do this cache check that we talked about, right? If we have a cache hit, we can just keep going. But if we don't have a cache hit, we're going to need to do our expensive computation, our slow path, and find the index, right? And that's what we talked about here, of looking up the index and this hash lookup that wasn't cheap. And so we'll do this expensive computation. And then our last step is going to be to set the instance variable to the value. With object shapes, this looks quite different. So the first thing we'll notice is that we're no longer comparing the class to whatever in the cache. Instead, we're going to compare the shape ID. So we'll say, hey, unless object.shapeID is the same as the shape ID in the cache. And our expensive computation is changing, right? That's going to change to iterating up this shape tree to find the index. So say we were at shape with ID 6, and we were looking for the index of name. We would go through this login edge, say, hey, that's not it, to shape with ID 5. Then we would see name. We would take our IV count -1, and that would be our index. But something we know is that, and this is a critical point coming up, the frozen status is encoded in the shape, right? The shape is already telling us if the object is frozen or not. So we only actually need to check this on the slow path. Consider that shape with ID 5 was the one that was cached. Say this is the cache shape. We know that because it's cached, we've already transitioned from this shape, right? We've already set an instance variable on this shape. That instance variable login, for instance. And so by definition, the shape can't be frozen. In order for the shape to be in the cache, it cannot be frozen. And so we don't have to do the frozen check at all on the fast path. And we can move it only into the slow path, right, where we're already having to do that expensive computation. And so we've made our fast path faster and reduced code complexity because we're removing this frozen check from that path. And then our last step, and our only step in the fast path, will be to just set the instance variable to the value. The second thing I want to talk about as an example of how we decreased code complexity by introducing object shapes are removing undef sets in object allocations. Now, what does this mean? Undef might sound familiar hopefully from the earlier slides. Say we have we're calling object.new, right? It's something we've done many, many times, or some class.new. We'll get back some object. And what's going on behind the scenes is Ruby is going to give us some piece of memory. And within that memory, it's going to say, hey, here's your space for instance variables. Some amount of instance variables. What that number is complicated. But some amount of instance variables. And then we can set these instance variables, right? We know by now we can set, say, instance variable A to the value nil. And it'll say, OK, your first instance variable, we know this, is now going to be nil. Something else we know we can do is call instance variables and just get back A, right? This makes sense. This snippet makes sense. And we know that A was this nil from our first case. But what's going on here, right? How did Ruby know not to give us back whatever happened to be in here? And it's because Ruby had already filled this in with undef. Undef and nil are not the same thing, and Ruby doesn't expose undef to us. Some other languages, like JavaScript, will show us undef and nil, and it's this funny thing where they're different types, but maybe, what do they mean, right? In Ruby, we just have nil. We don't actually see the undef. And so what that means is when we were calling object.new, instead of just this blank instance variables, we were filling all of these with undefs. And this operation of filling these undefs has both a performance and a complexity cost, right? Now we're going to be checking for undefs all over the place. And we have the performance cost of every time we allocate a new object, which happens quite a bit, we fill in all these undefs. So what's different with object shapes? Well, we know we have this undef shape, right? That must come in handy somewhere. And we know when we're looking at our instance variable array, we're really just iterating up the tree, right? So because we're iterating up the tree, we can account for whether an instance variable is defined or undefined through that way. And when we're calling object.new, we don't need to pre-populate with any undef values. We no longer need to do this at all because we're not looking in here, right? We're looking up the tree to get all the indexes. And so we can remove both the performance and the complexity cost there. I'm sorry about the audio. I don't know if I'm doing something weird. The next benefit I want to talk about is that it's beneficial for JITs, for just-in-time compilers. Matz talked briefly about JITs. I don't want to go too deep into it, but if you have questions here or you want to talk about YJIT or anything JIT related, please come find me afterwards. We'll just look high level. YJIT is a just-in-time compiler that my team at Shopify, Maxime specifically, led work on and put out last year. And the code it generates is like another way to think of this caching thing, right? It's caching instructions or kind of thinking ahead of where we are to try speed up our code overall. And shapes help this even more. If we look at instance variable get, and we're going to look at some code, but you don't really need it. We can fuzz it out kind of. Without object shapes, this was what get instance variable looked like in assembly. And with object shapes, it looks like this. And the big takeaway that I want you to get from this slide is that with object shapes, there's just less. There are fewer instructions, fewer comparisons, and fewer memory reads. And all of these things are going to make our code faster with YJIT. And there's even more potential here to make further improvements with shapes. And so the last thing we're going to talk about is performance, right? Let's look at some performance and some benefits. And we'll look at both RailsBench, which is a popular benchmarking library, and at micro benchmarks. So RailsBench, we can see this box plot. We measured average requests per second over 10 runs, where higher is better. And Ruby master, Ruby head was on the left, and Ruby with shapes is on the right here. And you can see shapes is higher. It's also more precise, right? You can see on the box plot, the values are closer together. And shapes is faster here on RailsBench in a significant way. The next thing I wanted to talk about is a few micro benchmarks. So Ruby has micro benchmarks within it. And the ones we cared about were the ones that were setting or getting IVARs of different types. And so that's why the names we'll see are a little different, but setting or getting IVARs. And this chart shows object shapes divided by master, which means that any value greater than 1 means shapes is faster. Any value at 1 or about 1 is the same speed. And less than 1 means master is faster. But these benchmarks have quite a bit of variability. So anything kind of within 2% here is a wash. It really changes run to run. But we can see we have quite a few benchmarks where shapes is faster, and 2 benchmarks at the top here where shapes is significantly faster. And I want to end on drilling into one of these benchmarks. So this VM IVAR init subclass benchmark. If we look at the code here, this is what it looks like, and we'll walk through what it's doing. The crux of the benchmark is measuring this b.set IVARs and c.set IVARs over and over and over again. And if we look up, we can see that class B and class C are both inheriting from class A, but they're different classes. So this is exactly the case we were talking about earlier, where we said we'll get cache misses with the way Ruby used to exist. And with Ruby with shapes, we'll get cache hits in these cases. And we're seeing it's more than 2 times as fast with object shapes, which is a significant improvement here. So we answered 3 questions today. We looked at what object shapes are, at how they're implemented, and lastly, we looked at why object shapes, what are the benefits here. Thank you so much. I want to especially thank Aaron Patterson, who's worked on this alongside me. If you're interested in following along, shapes actually recently merged into Ruby, but I'll post about it likely on Twitter. You can follow me here. I also just wanted to shout out, if you like conferences, which I would assume is all of us, there's a new conference that I'm organizing in a month called RubyConf Mini, which will take place on the East Coast of the US. If anyone is interested in coming, please look it up. And lastly, I just wanted to shout out, I also organize a women non-binary Ruby community called WNB.RB. We're virtual. If you're a woman or non-binary person, please join us. We'll also be meeting right after this today and going to a coffee shop together to get to know each other in person. Thanks so much again. I forgot to say. I can say, but I'll take questions after. Or if you want to say it. I don't know. I'll take it. Okay. If you have any questions, will you just come find me later today or tomorrow, and I would much rather have a discussion about them, so we can talk about it at any point. Just come find me.
Perfect. I love the slide with the explanation. Higher is better, faster with objects. Like, boom. Jemma, thank you so much. Right now, it's time for coffee. If you're into cookies or coffee bread, I have no clue what we're having. I think it's delicious. It's in the second floor area. You will find some snacks. Otherwise, it's coffee. Please be back at 3 o'clock. We still have 2 more great talks. Thank you so much.
Okay. I'm going to start with a security-related issue. It's not really an issue, but regarding the party tonight at Kaivohuone, take your badge with you. You will enter with the badge. Okay, everybody after me, let's all say together, I will take my badge. I will take my badge. Thank you, much appreciated. No, I just heard it, but really take it with you and it'll be a lot easier to get into. Otherwise, of course, the other option is that you will have to give a short presentation on object shapes, and that probably gets you into. Perfect. Hey, let's get going. 2 more great talks to follow. Now, it's getting close to Halloween. Security doesn't have to be scary. From this talk, you will learn 5 tips that can almost immediately make your code base more secure. So, security doesn't have to be a nightmare. Let's give a big, nice, warm welcome to Wiktoria Dalach. Wiktoria!
Imagine this. It's Monday, the last sprint of your project. And you just finished the planning, and you know that you need to deliver like 2 bugs, fix 2 bugs, and just edit and add some stuff to documentation. You feel good. It is achievable, and, well, you're also excited for the release and excited for the new project that will come later. You feel good. It's Monday, but it's a good Monday. Okay? On Tuesday, engineering manager comes into a room, awesome, and she says, you know, it would be great if we run this just before the release, if we run it through security. And in this case, exactly, and in this case, it would be great means we must do it. So you go to the meeting, with security team, and they ask you questions, and they ask questions about, oh, you can hear how I breathe. Okay, this is not the question they ask. They ask questions about the design, the documentation that you haven't finished yet, and, well, after this meeting, you end up with this. And if you ask me, I also have no idea what the snail is doing up there. It's a nightmare. It's a complete nightmare. And my friends, I'll be honest with you, I've been in this situation way too many times. And, you know, after the release, we would have this wonderful meeting called Project Retrospective. Do you know this meeting? And we would all agree that having security review in the last sprint just before the release is a nightmare. And the moment we finished the meeting, although we all agreed on that, the moment we finished the meeting, we would completely forget about it, and next time the situation will hunt us, and it would repeat itself. Last year, after, 8 years of writing software, I decided to switch to another team, and I joined security team. And during my transition from software engineer to security engineer, I, read some books, took some online classes on cybersecurity, and when I started working with engineering teams, I gained this new perspective, you know? And I realized that there are some things that you can do, and there are low-hanging fruit that you can do to improve the security of your product. So today, I will share those absolute, the lowest hanging fruit of security. But in the second part of my presentation, I will share with you a little piece of theory that completely blew my mind, okay? Are you with me? Wow, I even got a response. Okay, so first of all, a strawberry. Sanitize the input. You should never trust what you get from the user. Sanitization means to clean up the input from the potentially executable code. And we're lucky because we have sanitize helper in Rails, and for Ruby we have sanitize gem. So in reality it is very easy, fairly easy to sanitize the input, because of course sometimes you want to allow the user to, I don't know, insert a link or style their description. So it is fairly easy to do, but it can actually have a huge impact with preventing attacks like cross-site scripting, remote code execution, yes. So I said, like, nothing controversial. Low-hanging fruit, sanitize all the data that you get from the user. Another low-hanging fruit, a blueberry, validate the data. You need to understand and you need to remember that the database is the most important asset you have. You need to protect it, because people will forgive you if you cannot access your service for 15 hours, but they will not forgive you if you lose their cat's pictures. So make sure to validate all the data you get from the user and all the data that you want to save in the database. So we tend to validate only a few fields. It's important to validate all of them. Low-hanging fruit. And with those, by implementing sanitization and validation, you will reduce the risk of cross-site scripting, remote code executions, SQL injection, and many more. The other thing, no credentials in the repo. And I know that some of you can have this question in your mind, but for testing it's okay. Well, it's not okay. Because we tend to forget, by credentials I mean username, password, API token, access keys. So we don't want that in the repositories because, well, you forget about it easily because we have so much work to do. And then you add another resource to this testing key or testing token. And then you lose control over what this token is responsible for, what resources can be accessed with it. And trust me, you don't want to wake up to a lovely email from a security researcher who found in a testing repository an API token that would enable the attacker to see the whole organization in the CI service that somebody uses, and effectively to just freeze the deploys of the whole product. So no credentials in your repo. The good news is, though, that many of these things you can delegate to the machines and to robots. I really wanted to use a robot emoji in this presentation. I'm glad I managed to do it. You may ask me, okay, but, well, I can see it's not a strawberry, I can see it's not a blueberry, it's a pear, and pear, it's not as low-hanging fruit, but it's still reachable. And it's a pear because it will require you to talk to people in your company who can spend money. Because by delegating your work to machines, I mean implementing scanning tools. The most popular scanning tools are SAST and DAST tools. DAST stands for Dynamic Application Security Testing, and it's a service that interacts with your front end. I mean, not your front end, sorry. The front end of your web app. And it feeds the front end with malicious input and looks for the response. Sometimes it finds something, so it will report to you a potential vulnerability. The other type of scanners are SAST tools, which is static application security testing. And this tool interacts with your code base, and it goes through your code base and searches for potential vulnerabilities. With SAST, it's pretty nice because you can have those tools integrated into your workflow on GitHub or GitLab, and when you create a PR, when you commit new commits, you can get like instant feedback. Oh, here you committed a credential, or here you introduce a potential SQL injection. So these tools are awesome, and I think we should use it because security is hard enough, and I mean, development is hard enough, and adding to that security is like a big pill to swallow. So whenever you have a chance to automate your security, you should definitely invest into it, and I highly encourage you to do so. Okay, so I've been speaking for 10 minutes already. How are you feeling? Like, I was right that low-hanging fruit, right? Nothing super controversial, right? Yeah? Okay, I'm so glad that I can see your faces because it's much more reassuring. Okay, so now I will take a sip. I hope you didn't hear it. Okay, so now I will share something that completely blew my mind when I learned about it. And I hope it will, I don't know, spark a fire in your heart. Okay, so before I tell you about it, we need to be honest. What is the problem with security? Well, security is just this ocean of topics. There is no one security. And if I asked each of you, is your product secure? Is your app secure? You all would give me different answers. Security is such a wide topic. It's application security, infrastructure security, IT security, password management, secret management, phishing, vulnerabilities, so much. So I think it is a little bit unfair to like, we have so much work to do as developers. We need to write good code, test it, make it accessible, and then somewhere at the end we need to take care of security. And it's a big task because security is such a big ocean of topics that is pretty much overwhelming and definitely intimidating. Look, when I when I was like mentoring like younger people, I knew that I tend to have to use the developers lingo that we all have, right? Especially if you're not an English native speaker. For example, I'm Polish, so I would use English words for like commit or push, like as Polish words, which made me completely like very difficult to understand for people who didn't know this lingo, right? People from security use acronyms for everything. And all of those acronyms, I kid you not, include either C or S. So good luck. And they do use them as verbs. So I spent many months of my first months in the team, like Googling every day 3 to 5 different acronyms. Security is intimidating, and security experts are partly to blame. So we have this ocean of topics, right? And security community agrees that the problem is that when you have an application and you try to secure it, there is an infinite amount of threats. Okay, infinite. This is why it's so hard. But, and this is the mind-blowing part. Are you with me? All of those threats, this ocean, can be assigned to 3 categories. Only 3. And the good news for you is you already know the acronym, because those categories are confidentiality, integrity, and availability, which are called the CIA triad. I will not make a spy joke, because the only spies I like to talk about are Spice Girls. 90s kids, I knew you would understand it. Okay. Okay, so this is mind-blowing, people. Let's not be distracted by pop culture icons of 90s, because 3 categories, infinite number of threats and 3 categories? Wow. Before I tell you, though, what is so groundbreaking about it and completely blew me away, let us establish the definitions of those 3 things so we all are talking about the same thing. Confidentiality. We want secrets to be secret. If I send an email to you, we only want to be the only person who can access them. We don't want anyone to read in between those emails. We want our passwords to be secret as well. Integrity means that we get what we expect. If you log into your Twitter account, you want to see all of the tweets that you have ever tweeted. You don't want to see no tweets, right? This is integrity. Availability is that we can access the information always. I mean, after the talk, we know that 100% is not the goal, 99.99% of the time. But this is basically availability. So, okay, we know that. We know what confidentiality, integrity, availability stands for. The infinite amount of threats. So what? Why was it so exciting to me? Why did I come from Berlin to talk to you about it? And why did I think that it's worth it? Because, my friends, the CIA triad can completely transform the way we approach security. Because instead of focusing on those threats that we cannot even count, we need to focus on only 3 things. confidentiality, integrity, and availability. And how do you do that? For each project, for each user story, ask this one question. How can the CAI of this project be broken? And it is a beautiful concept, because it will work for every technology you will ever work with. No matter if you're back-end, front-end, mobile, DevOps, you always can ask this question. How can the confidentiality, integrity, and availability be broken? And of course, those questions will vary depending on what you are working on, but the baseline stays the same. And in order to make it slightly more clear to you, I will now share some examples of those questions. For confidentiality, you can ask, who can see this resource? How do we store credentials? But also a confidentiality question is, what do we put in our logs? Do we log any sensitive data? Any tokens, usernames, etc.? For integrity, of course, the basic question is who can create, update, and delete this resource? But also, if something bad happens, is there a way for us to see a malicious actor deleting all our customers' data? Do we have a way to monitor that? Do we have the way to alert them about it? Another integrity question, what happens when malicious actor sends malicious data to our API or via some form? And availability, of course, when I talk about availability, everyone is like, oh, availability threat, DDoS attack, distributed denial of service, so this is infrastructure. We don't have to care. But the truth is that we as developers are highly responsible for availability because we introduce other products to our product. Which means we create new dependencies. And now the great question for availability is, what will happen with our product if this wonderful piece of software that helps us manage feature flags is down? Here I have an anecdote. So I don't know, like a few years ago, I think 7 or 8, I had the pleasure of implementing billing system. Have anyone ever had billing? Yeah, okay. So if you sell for Europe, sell in Europe, your product in Europe, to a customer who's also a business, there is this wonderful tax identification number called VAT ID. Do you know that? Do you? Yeah, okay. So, and what happens then if your customer provides it, then they pay for your product less. They pay without the tax. So you don't only have to accept this VAT number, but you need to validate it, right? So I don't know, I hope it has changed, but 8 years ago, in order to validate the VAT number, you had to send a request to a European system called VIES. Anyone familiar with it? Yeah, okay. And yeah, and they would, respond with, yeah, this is a valid number. No, it's not valid. And then it would influence the price. So what happened was that we had a very successful launch of the product, and yeah, we got rate limited, like 1 hour in. So what would we do with that? Like, we cannot just close and say, oh, we just launched a product, sorry, our website is unavailable, you cannot create new orders. Because who does that? It's such a waste of money. So we had to, luckily we were prepared for that, and we had to find a workaround around the situation. But this is just an example of availability question that you can ask. And also, when you run a migration, you need to know how long this migration takes and what will happen if this will influence the availability of your product. Asking those questions, asking the CIA questions will help you create much more secure solutions and software. And I encourage you, of course, you can do it for a big project, you can do it for a user story. I encourage you to do it for the whole project early in the design phase, which is a nice segue to my last point, shifting security left. So if you talk to any application security expert and you ask them what's new, what's hot in the industry, they will tell you about shifting security left. Because, well, security experts realize that having the security review just before the release is not experience for anyone, not only for developers, because it adds work and it's much more stressful, but also for security engineers. Having spoken to many of them, I know that they would love to be enablers. They would love to be helpers who help you, sorry for repetition, create the best software. But when you talk to them at the end of your process, then they sometimes need to block you, and it sucks for them too. So right now, this hot topic, shift security left, means basically that when you look at software development lifecycle, and it has traditionally 6 phases: analyze, design, develop, test, release, and maintain. Instead of doing the security review at the end of the process, you want to shift it left, which means engage with security team in the design phase. And you can use CIA Triad as a basic framework of approaching this. And I do encourage you to do so, because you'll be happier and they will be much happier. Also, what is important is that any change that touches the code is expensive. And changes that are made in the code that is already on production are super expensive. And they will definitely take much more time than you anticipated. So by shifting security left, by talking to security and tackling security in the design phase, the changes are fast, cheap, and easy, because usually they happen on a piece of paper or a digital piece of paper. But it's much easier to do so in the design phase. There is no week where we don't hear about a data breach or vulnerability that is in a very popular library. And customers look at that, and they don't want to risk their reputation, their money, their data. Therefore, security becomes more and more relevant topic when it comes to sales negotiations. People don't want to spend money on products that are not necessarily secure. And I think not only that is important, but also, if we're engineers, we need to, I think, acknowledge that the careless times of move fast and break things are over, because our customers, our users trust us with very personal, sometimes even intimate data. And we, as engineers, need to, I think we owe them the effort of doing our best to create the most secure solutions for our users. I hope my talk brought security a little bit closer to you, and I wish you a very pleasant afternoon, and thank you for listening.
Wiktoria, thank you so much. Plenty of questions. Please vote. Please ask more questions. First one from Stefan. What are your thoughts about storing credentials in encrypted form, as, for example, possible in Rails?
I don't have much experience in that. Secret management is a huge topic anyway. If you have, we can discuss it later. But overall, I have no experience with that. We moved from storing any kind of credentials to AWS Secret Manager. So, yeah.
Okay. Then there's a question from the well-known Anonymous. How do you apply a CIA triad to a big and old code base?
Step by step. Overall, in order to... I have so many ideas. Please talk to me, Anonymous. But the thing is that what you want, you want to automate security. Therefore, for example, scanners would be a huge help if you have a big code base of legacy code. Also, the CIA triad should be a part of your designing process, and you can do it by, in a way, injecting it into your design, product briefs, design documentation, etc. So it, of course, won't happen, overnight, but there are ways to make your software development lifecycle more secure.
Excellent. You said, this is from Threat, you said, let the machines do the work. What are your favorite libraries, gems, services that provide security analysis and or monitoring?
We used commercial tools for that. So I don't have any open source examples to give here.
One is, how do I remove credentials from the Git history of an active project with about a dozen people currently working on it? Send help.
Yeah, this is a huge problem, and we went through it. We went through it 2 years ago. And yeah, it's a huge effort, but it's definitely worth it. There are ways to do it. Please, you can talk to me about it. But definitely, you need to have, overall, you need to have a consensus in your engineering department that this is something you need to focus as one of the security priorities for, I don't know, half of a year or something. And then you, of course, choose the right provider for security management, secret management, and gradually you move away from those credentials.
Secret management sounds a lot like Mordor stuff. Matthias is asking, can you recommend specific Dust or SAST services or tools?
There are plenty. I have the most experience with Detectify as the Dust, and SAST was made in Polaris. Yes. I remember the names. Wow. Yeah, but there are plenty, and I think you should go through the research with your security team. Like this, it's money, so you need to choose wisely and what's the best for your product and for your needs.
Great. Manuel has a question. How can we guarantee secure coding practices in an organization with hundreds of developers?
How can we guarantee, what is engineering? Like, do we have any... So it's a huge problem, Manuel, and I completely empathize with you because it is a challenge. But the thing is that, we need to... I think maybe for some reason we take this word too lightly. We can aspire to be engineers, I think. And there is no, security needs to be the part of engineering because the data that we have access to and the impact we have on real people's life is just too big. And so I think it's a mix of cultural, priorities and engineering priorities, and also tools that can help remind people about security during their practice. So implementing SAST scans into PRs, having secure development lifecycle, etc. It's a river. I can go on and go on.
Still a couple quick ones, I think. What are your thoughts on third-party authentication versus implementing your own?
You should always, everything is a risk, and you need to manage this risk. There is no one good answer for everyone. You need to you need to threat model and think about the risk. What's the lesser evil, basically.
And an honest question from Juan. As a lazy person, is there a VS Code plugin for this?
Great question, Juan. Juan? No, what's the name?
It is Juan.
Juan. Great question. Because if you have, for example, if you use some SAST or DAST tools, for Polaris, definitely there is a VS Code plugin. So you can have it integrated into your VS Code, yes.
I just want to take this, I don't know if you already answered, but what would you recommend to handle secrets in production?
Yeah, definitely don't put them into a repository. There is, I forgot. We have a secret manager from AWS, but also there is Vault, I think, FAULT, if I'm not mistaken, and they have solutions for that as well.
At this point, Wiktoria, thank you so much.
Thank you very much.
You have just time for a quick coffee, but please be back in just about 8 minutes for looking into Peephole optimizations in 8 minutes. Thank you. And here we go. Time for the last talk of the first day. It's been a great day, exciting talks, a lot of chatter around, really, really nice. Tonight, the party will start at 7:30. You'll find the directions on the website, on the app. The official part will end at midnight. So it's kind of... Thank you. The next official part starts at 9:40. That's the breakfast. So if you left by midnight, you went to the hotel, you got a good 7.5 hours sleep, you'll be fine. 9:40, breakfast. And then after 10 o'clock, we'll start with the program. So we are all set. And you remember, you promised yourself, I will take my badge. I will not lose my badge. I will take... we're all there. But seriously, if you have an issue with your badge, you're missing it, whatnot, after this last talk, in the atrium behind the venue, there will be crew members who will assist you if you have a problem with your badge. Okay, enough of the badges. We don't need no stinking badges. Okay, excellent. The next speaker will take questions after the talk, here in front of the stage, live. Let's learn about various Peephole optimizations used to make bytecode generated by the Ruby compiler more performant. Do these small changes make any impact on the final runtime? Let's find out. Experience reading bytecode is not needed. So, looking into Peephole optimizations, save the best for last, Maple.
Hi, everyone. Hi, I'm Maple. Today we'll be looking into Peephole optimizations. But before we start, I want to share something. So I recently quit my job. And so I've come to learn the importance of having a community. And so I'm actually here today with you because I'm sponsored by WM-Beta-RB. I know Jemma has already said something about this, but I just wanted to share that this community has been really helpful to me. So if you are a woman or a non-binary folk, please join us, and we'll be meeting right after this talk at Espresso House Hakanemi. So I hope to see you there. It'll be really fun. All right. So looking into Peephole optimizations. So Peephole optimization is an established technique that was written about back in the 60s. And that was a really long time ago. So this is the earliest paper I could find on the topic. So I think it's really, really interesting to learn such an established technique, optimization like that, because it helps us understand how the system works overall, and it builds our foundational knowledge to future compiler optimizations. So if you have compiler experience, I hope this talk will refresh your memory on the topic, and you'll also learn something new about how Ruby does Peephole optimization specifically. And if you're a total beginner, then I am you. I've written this talk just for you. I hope you will feel like you learn more about how how Ruby is compiled, and also how specifically this optimization works. So what to expect from this talk? First, we're going to talk about, obviously, what is Peephole optimization. We're also going to talk about when does Peephole optimization happen in Ruby, and how Ruby implements Peephole optimization. And we're going to go into examples of Peephole optimizations in Ruby. And in doing so, we're going to learn about some YARV instructions. So YARV is a Ruby VM. It's called yet another Ruby VM. And then we'll talk about some of how the bytecode works and all that. It'll be really fun. And then finally, we'll end with big picture and benchmarks. So what exactly is Peephole optimization? So it involves looking at a small set of code, usually intermediary instructions or bytecode, to find and change the instructions to be more performant in some way. And so the resulting instructions are usually less redundant and less complex. So how does it get its name? So the reason why it's called Peephole is because it looks at several instructions at once. I don't really know why it's, I mean, because, you know, in a peephole, you can only see what's directly in front of you, I guess. But, you know, peephole nowadays, you can kind of see, like, the whole view. So I don't know why it's named that. So this optimization can be applied to various other languages and machines. So, for example, peephole optimization is also used in languages like Python. It can also be used to optimize assembly code, and YJIT also uses it to optimize their bytecode. But today, we'll be talking about it in the context of Ruby, so MRI. And this is just a paper I found. So peephole optimizations are also used to, could also be used to optimize quantum compilers, which is really cool. So another note is that Ruby currently implements peephole optimization already. So you use it in your Ruby code. It's turned on by default. All right. So when does peephole optimization happen in Ruby? So this is a graph of essentially the entire Ruby execution process. So it starts from your Ruby code, which gets passed into a tokenizer, which produces tokens. That gets passed into a parser, which produces AST nodes, to the compiler, which produces bytecode. And that bytecode gets executed by the virtual machine. So the phase that we're talking about in this talk would be the compiler and bytecode phase, where the compiler generates bytecode. So let's zoom in a little into this specific phase, and let's use this as an example. Essentially, we have a puts 9 + 8 string into the variable source code. And you can kind of ignore this graph on the left. It's essentially what the puts 9 + 8 source code is represented in AST nodes, and that gets passed into the compiler. But let's take a look at what the bytecode looks like. So in order to do that, we use this library called the Ruby VM instruction sequence library. And what we want to do is we use the method called compile that takes in the source code. And then we want to disassemble it, because when the Ruby code is compiled, it's not readable. And then when we disassemble it, it is human readable. Next, this is the output. So don't get overwhelmed. I just want to show you kind of what it looks like. But the main thing to focus on is essentially this little chunk, which is the bytecode instructions, or the YARV instructions. And so we can conclude now that this is the output. Oops, this is the output of the compiler. It's kind of simplified. It's essentially the same as what the code output in the previous slide. All right. So another thing that you have to know is that when the compiler outputs this bytecode, it's actually arranged in a linked list structure before it is passed on to the Ruby VM. So just pulling back now to how this relates to peephole optimization, when the compiler generates the bytecode, it is then optimized into more optimized bytecode before it is actually passed to the virtual machine to be executed. So that brings us into the next part, which is how does Ruby implement peephole optimization? And to avoid showing you a bunch of C code, I have kind of I wrote this pseudocode of iseek optimize. So iseek optimize is a function in compile.c in the Ruby implementation. So let's kind of walk through it. The first thing it does is set up some optimization options, obviously, because it's C, so we have to set up some stuff. And then we iterate over the linked list, so in a while loop. So for each element, we do this. Next, we check if the element is an instruction sequence. So there are different elements, which we won't go into here, but what we care about is an instruction sequence. So if it is an instruction sequence, and if peephole optimization is turned on, which we know is turned on by default, but you can change it, obviously, we want to call the function iseek peephole optimize. After that, there are various other optimizations, which we won't go into in this talk. And then we move on to the next element, because it is a linked list. OK, so just to quickly show you visually, what it does is that it essentially traverses the linked list. All right, so now the question is, what happens in iSeek Peephole optimize, which is the C function that we call within that if condition? It's very long. OK, it's very long, but I highly recommend checking it out after this talk if you're curious to what other Peephole optimization cases there are, because it's pretty well documented. You can see it, but it's for each case, it is there's a comment on like what the before and after is of the bytecode. But anyway, moving on. It's a bunch of if conditions, but I kind of simplified it for you a little bit here in this pseudocode. Essentially, for each element that we're checking, we want to see if it matches any of the cases of the optimizers. So before you say anything, yes, it's basically like a pattern matching function. It's like pattern matching and then conditional replacement if it matches that case. And just a fun fact, I actually did a survey of the entire function, and there's actually like 20 to 30 cases of Peephole optimization cases out there, so that's pretty cool. And also, if you're curious, there's actually a paper out there that implements Peephole optimization in a pattern matching kind of sequence. So if you are interested in pattern matching, you should check this out. All right, to recap, iSeek optimize, so the first C function that I showed you, essentially traverses each element, and then we call iSeek Peephole optimize to check. So this is what happens. So when it reaches an instruction that is the optimization case, what we do is ask whether it matches, and if it matches, we replace it to a more efficient instruction, and then we move on. So essentially, that's how Ruby implements Peephole optimization. So after the Peephole optimization pass, the instruction sequences should be smaller in size and also more performant. And you'll kind of see what I mean in just a second. So next part is, I think, the more interesting parts, which is examples of Peephole optimizations in Ruby. So the first example I'm going to show you is combining multiple instructions into one single instruction. And the source code will be this. So if you didn't know, this is essentially a range from A to Z. And the double full stop is to indicate that it's inclusive. So for example, you can call count on it, and it will return 26, because there are 26 alphabets. And you can also call 2A on it, which gives you an array of letters. So what we want to do is very similar to the first bunch of code that I showed you, except in this case, we're going to turn Peephole optimization off. And let's take a look at what the output for this is. So similar to before, this is the the bytecode output, but I've simplified it for you. So essentially, it is put string A, put string Z, new range with the argument 0, and we'll see what that means in just a second, and then we leave, which is the equivalent of returning. So the first instruction is put string A. Put string A essentially pushes a string literal onto the stack. And put string A pushes A, put string Z pushes Z. And the next one is new range with the argument 0. And new range creates a range, and it takes one argument, which is 0 if the n is included, or 1 if the n is excluded. So we know that it's 0 because, as I mentioned before, it's 2 full stops, and so it's inclusive. So let's take a look at how the Ruby VM executes these instructions. So if you didn't know, the Ruby VM uses an internal stack to manage values. So you'll see how it works in just a second. So let's go through the instructions. So put string A pushes A, put string Z pushes Z, and then we call new range, which pops 2 elements off the stack. And pushes a range, A to Z, back onto the stack that is inclusive because the argument is 0. And then we leave. So I want you to make note of what value is on the stack right now. OK, let's take a breath. Next, we're going to see how Ruby optimizes it. So with Peephole optimization turned on, this is the output. It's just 2 instructions. And we have put object A to Z. So put object essentially pushes a known value onto the stack. So you can kind of see where this is going. Basically, this. You just push the range. And it returns the same value. And this is the diff. So instead of having 3 instructions do the same thing, we just have put object with the range that you want. So I ran a micro benchmark on this, and it's actually 5.4 times faster. So that's really cool. OK, so moving on to the next example. Removing unnecessary instructions. So this is a very contrived example, but essentially, it is hello world in an array that is splatted. And if you didn't know, this kind of returns an array of just hello world when it's run. So doing the same thing, we want to turn off Peephole optimization and see what it returns. So OK, this is the simplified version. We already know what pushString does, so let's skip that. There's a new instruction here called new array, which takes in the argument 2. And new array puts a new array initialized with the size value from the stack. So what that means is that it pops the stack however many times it is specified in the argument, creates a new array, and pushes it back onto the stack. And another new instruction here is splat array. So splat array essentially calls to on an array to splat it. So the reason why we have splat array is because we can't assume that whatever is on the stack is an array. And so splat array exists to make sure that we're actually executing an array. All right, so let's take a look at how the Ruby VM would, or Yarv would execute these instructions. PutString hello pushes hello. PutString world pushes world. And then we call new array 2, which pops 2 elements off the stack and pushes a new array with the 2 elements. And then we call splat array, which pops something off the stack, calls 2A on it, and then pushes it back onto the stack. And then we leave. So I want you to take a second to see if you notice any redundancies. And then let's take a look at how Ruby would optimize this with Peephole optimization turned on. And this is the output. And essentially, you can see that we actually don't have splat array anymore. And the reason is because we don't need splat array, because we know that new array 2 always returns an array onto the stack. And so we can save on 1 instruction. So I did a micro benchmark on this. It is 1.31 times faster. All right, so to the next example. Removing redundant instructions. It's kind of similar to removing unnecessary instructions, but anyway. So this is the example code. So we have gummies are the best, which they are in the string, and then we assign it to x. And then for some reason, we want to assign x to x again. So yesterday, while I was preparing this talk, I showed this to Jean, who most of you will know as Beirut. And I'm like, who's ever going to do x equals x? Turns out he just wrote this code last week, which is essentially x equals x, because I checked. And this is actually a Rails PR. So this code is in Rails. And I checked because the Peephole optimization is actually works on this Ruby source code. So that's pretty cool. OK, anyway, moving on. What we want to do is turn off Peephole optimization. This is the output. And this is the simplified output. So there are a couple of new instructions here. So the first one is set local with index 0, and set local essentially sets the value of the local variable on a frame. And the reason why previously you'll see that it's index 0 is because we only have one local variable, which is x, and so we set it to x. And then the next one is get local, and similarly, it fetches the value of the local variable from a frame. And the third new instruction here is dupe. So dupe copies the top value of the stack and pushes it onto the stack. But in this case, the dupe instruction just duplicates the pointer reference of the top object on the stack. It doesn't actually make a copy of that object. So let's take a look at how your BVM would execute these instructions. Put string, we know, push string onto the stack. And then set local at index 0. We pop the first object of the stack and set it. Just a note here, this is just for visualization purposes, but in reality, Ruby actually manages local variables a little differently. There's a separate local table here just for you to understand it. But anyway, so we set x to be gummies are the best. And then we get local, which looks up in the local table what x is, and then push that onto the stack. And then we dupe it. And then we set local again. But, you know, it's already set. So you can kind of see where I'm going with this. And then we leave. So with Peephole optimization turned on, this is the output. And yeah, wait. So this is the instruction. So let's take a look at how the Ruby VM would execute it. And you can pretty much see where I'm going with this. So we push gummies are the best onto the stack, set the local variable, and then get the local variable, which is the x equals x part of the Ruby source code. And then we leave. So this is the difference in the optimization versus no optimization. And let's take a look at the benchmarks for this. So surprisingly, or maybe not so surprisingly, there is no difference. It's not slower. It's kind of marginally faster. But there's no huge difference in CPU performance. But this kind of makes sense because as I've alluded to just now, when I was talking about dupe, dupe does not cost a lot to execute because it's just a pointer duplication and not a copy of an object. So this is an example of kind of a cleanup optimization where it makes the code less complex. And in turn, does save us on instruction sequence memory size. All right, so moving on to the last example, it is using more efficient instructions. So the example code for this is an array containing 1 and 2, which is assigned to the variable foo, and then we split foo in an array with 3. Okay, so you know the drill. We turn off optimization, and this is the output. This is the simplified version. We can see that dupe array is not something we've seen before. Let's take a look. Dupe array copies a literal array and pushes it onto the stack. And concat array, so we kind of know what set local is, get local is, split array, I've talked about it before, and then dupe array. But now we have concat array, and concat array pops 2 objects off the stack and concatenate them, and then pushes it back onto the stack. So let's take a quick look at visually how it happens. So dupe array pushes 1 and 2 onto the stack. Set local sets it to the local table, and then get local gets it. Split array pops it off the stack, pushes back on. Sorry, I know I'm essentially narrating what's going on, and you can obviously see it. And dupe array pushes 3 onto the stack, and then concat array pops 2 objects off the stack, concatenates it, and pushes it back onto the stack, and then we leave. All right. So with Peephole optimization turned on, this is the output. It's not very obvious what changed because it is the same amount of instructions. But here's the diff. Essentially, we swap out dupe array 3 for put object 3. And the reason is because dupe array allocates a new array while put object does not. So this optimization actually runs 1.26 times faster. So those are the examples that I have. Let's talk about the limitations of Peephole optimization. As you can already, as you probably have noticed, this optimization kind of only applies to very specific bytecode. We're not all Jean writing x equals x all the time because it's literally an edge case. So it kind of may not apply sometimes when we write day-to-day Ruby code. Next, Peephole optimization gives us, Peephole optimization only has a limited view into the code to make optimization decisions. And a couple of talks already have mentioned this, but Ruby is a dynamic language, so it's very hard to get information at compile time. So for example, Ruby methods can be monkey patched. So we won't know until runtime which method we're actually going to be calling. We also can't do stuff like get rid of unused local variables, because some of them potentially need to stick around if binding is called. And some optimizations that are common to statically typed languages, such as algebraic simplification or expression rearrangement, is also really hard to do with Ruby for that reason. And finally, Ruby does not yet inline methods, so people could potentially work more effectively with method inlining in Ruby, which hopefully we will get in the future. So one question that you might be wondering while listening to me up here right now is that why doesn't the compiler just generate optimized bytecode? Like, why do we need to have this optimization pass? And the reason is because of the way that the compiler is implemented. It is unable to see the bigger picture, because essentially what it does is translate the AST nodes into bytecode. And so it kind of makes sense to split up the responsibilities of the compilation and optimization process. All right. So another limitation is that, at least in Ruby, these optimizations have to be found and written by humans. And what that means is that it's not super optimized. There might be better optimizations out there, but we won't know until we find out. And there is Peephole super optimizers out there, but it's just not implemented in Ruby. All right, so I'm going to share with you some benchmarks. Using an established benchmarking library called YJitBench, you've probably heard of it. I ran benchmarks that measures I ran benchmarks with both the Peephole optimization turn on and the Peephole optimization turn off. So essentially, it shows some modest improvements with the Peephole optimization turn on, which you can see in the last column over there. All right, so one thing to note is that on top of the performance improvements, which I just showed, there's also a reduction in instructions emitted. So in turn, also the reduction of the total memory space used. So it's not just CPU improvements, it's also a reduction in memory space. All right, so essentially, this is towards the end of the talk. I wanted to share with you this YARV documentation that was written by Kevin Newton. If you're interested in checking out what the bytecode instructions do, please check out this library. It's really good. It essentially implements YARV in Ruby, which makes it easier for all of us to understand, I'm sure. And then another thing that I wanted to share is this PR by John from GitHub. I mentioned before that Peephole optimizations are found and implemented by humans. So it's essentially what he did in this PR, which that he noticed that there was a case that could be improved. And it is the example that I showed you where he swapped out dupe array for a more efficient instruction put object. And so hopefully you feel like you kind of know what to look for if you're ever interested in diving into this. I haven't really told you how to potentially write your own Peephole optimization, but I think you have the tools. And these are the links to the two resources that I shared. And that is all. Thank you so much for listening. It's an honor to be here. If you're interested in having in attending the WMB.RB meetup, we'll be meeting somewhere in this room and walking to the coffee shop together.
Excellent. One more time, big applause. Mate Long, thank you so much. Excellent. A big thank you for everybody showing up today. Live events are nothing without audience participants. Thank you so much. Tonight, 7:30, party, badge, badge, badge. Don't lose it. Breakfast, 9:40. Questions? No, thank you. Thank you. Bye.